All right. Good morning. Good morning to all of you. Let's have
Morning.
ourselves for this prayer. Oh Lord, thank you for the gift of life that you've given us. We thank you that you've enabled us to see another day, add another day into our lives. Lord, as we come for this lesson, I pray that you may protect us, you may guide us on what we are going to learn and understand it, Lord. I'm praying that you may bless our teacher who's going to teach us and continue to teach other more people and inspire them. In Jesus' name I have prayed.
Amen. Thank you for the word of prayer, Imran. Yes, so we are going to start another section. I'm very happy for the people who really tried, who did the numbers. I was able to see some of you send your work. That was really very good. So today our focus is going to be on geometry and measures. So this is the element of construct we are going to touch, and then afterwards we shall discuss the way forward. But this is the part that we are going to deal with in our lesson today. Now, when they talk about measurements and geometry, these are the topics you should expect. Yes, and we said that for the new curriculum, when they bring for you the scenario, it can capture very many topics. So for this particular one that we are going to be concentrating on today, the topic is going to be, or the questions are going to be capturing those three. They are going to capture bearings, angle properties, then time and timetables. Then in case tomorrow time allows, then we can look at business math as an independent number. Then we shall also look at the three dimensions, God willing. So today our focus is going to be on bearings, and I'm intentional for all the numbers that we are doing. And when it comes to bearings, these are the numbers that I wish you always to score 20 out of 20 with good preparations, because you have an idea already from your primary school, meaning that here it's very, very easy for you to score everything. But for some of the mock papers that we looked through, you can notice that they brought numbers on bearing. But barely do the candidates get more than 10 on that number. But why? Because of the few errors and some of the things that they took for granted that maybe they were easy and they didn't pay a lot of attention to it. Now, when we are doing bearings, the first thing I want you to give attention to is the key points when it comes to bearings. The first thing you need now to know when it comes to bearing is that always when you are making any measurement when it comes to bearings, always we start from the north line. So never measure from any other part. So when we are measuring, always we start from the north line. Whenever you have your compass direction and you are going to take any measurement, always we start from this north line, and always we are going in the clockwise. Clockwise is the way the clock moves. So you look at your clock in the room, the way the clock moves, the clock will always move like that. So that is how we always measure our angles. In other words, north is the 0, 0, 0 degrees. So your first angle, when the angles are increasing, this one, let me say it can be 30, this one can be maybe 45, this one can be 70, this is 90. So your angles always are increasing in the clockwise direction. So when you are placing your protractor for you to measure, always you place it in this format here. In this format here, and then you measure off. So that is how you are supposed to measure. In other words, when you are measuring and you have placed your protractor, always use the outer scale. When you place your protractor like this, always we are using the outer scale. So the outer scale, remember your protractor has two scales. It has the inner one and the outer one. So always use the outer scale, which has 10, 20, 30, and the rest of that. So you don't use the inner scale. Number three, bearings, always we state using the 3 digits. So when you are stating your bearings, always we use 3 degrees. Don't never write 45 degrees. This is just an angle. But if they tell you state the bearing, describe the direction, always we use 3 letter digits. So remember, I've told you that now north is the 0. So in case you are giving a bearing, let me say a bearing around here, and you have noticed that when you make your measurement here is 45 degrees. So your bearing here, since we start from the north, we shall write it as 0, 45 degrees. Alternatively, if you don't write it like this, then you know that I always start from the north and I go towards the east. So I can write it as north 45 degrees east. So when you put the compass points, the north and the east, then there is no need for you to put the 0. The 0 shows us that you are starting from the north and you are turning in the clockwise direction. So you can use any of the two. You can either use this one or use this one. But the best is using these 3 digits. Yeah. So, and whenever you find in bearings, whenever you find a number, let me say you find 130 degrees, they give you 140 degrees like that. This one is an indicator that they have started to measure from the north and they are going towards the east, or they are going in the clockwise direction. If you find 240, 250, for you make your measurements starting from the north, then go in the clockwise direction in bearings. So never start from any other part. Always start from the north and then move towards the other direction. Secondly, or another thing you need to know when it comes to bearings, please now take note that now they may not specify for you the angles. They can say the person moved due east, the person moved due this, or the person moved like that. Now you need to know that north is always 0 degrees. That one you draw it the way it is. When it comes to east, this one is always, the angle we have here is 90 degrees. And then here is where we have our south, and here is where we have our west. So meaning that when they tell you that someone moved in the northeast, this is the north, remember. Northeast, it means that the degrees someone has turned through are 45 degrees. Now, this is where I want also to now to emphasize. When you are indicating your bearings, you are indicating 45 on your diagram. If it is a bearing and you are indicating 45, I will always indicate 0, 45 degrees. Now, if I don't write it like that, then for you now, you write like this. You write here, you draw an arrow, and then here, for you put 45 degrees, and then you put an arrow to show that you have started from the north and you are going towards the east. So those are the 2 ways, but the best is using this to show that now that is 0, 40, 45, meaning that you have started from the north and you have gone, because here we are indicating bearings and we are not indicating angles. So these are bearings, but not just angles. For you just writing 45 degrees, that is an angle. But putting 3 degrees is what shows that you are now dealing with the bearings. And you just need to know that when we talk about bearings, it's just a way of describing the direction, but using angles. So the way of how we can describe any direction, but when you are using angles. So when they say southeast, now you need to know southeast is here down. So how many degrees do you turn to reach southeast? Either you start from the south and you move 45 degrees, or you move from the north and then you come in the clockwise direction. Do not confuse the bearings with the trigonometry. Remember, for trigonometry, we move in the counter-clockwise direction. But in bearings, in mathematics, is the only topic where we move in the clockwise direction when we are taking the angles. So you must pay attention to it for anything. Now, someone has asked, what about when they say north, 45 degrees west? Yes, still, even when they say that one, still you have to come back. You have to come back and say, what does it mean? So when they say north, 45 degrees west, it means that you're going to draw your compass very well. This is the north. Now, this one means that from north line, turn 45 degrees towards the west. This is where the west is. So meaning that you're going to start from the north and you turn like that towards the west and you turn 45 degrees. So now that means that your compass point is going to be here. So it's going to be here. That is the direction you are going to take. In case they tell you west 30 degrees towards the south, it means you are going to start making or measuring from the west and you turn towards the south. So here you'll only turn 30 degrees. So always the first letter shows you where you are going to place your protractor, along which line are you going to place your protractor. And then the angle shows you the direction you are going to take. So when they say north 45 towards the west, it means you are going to move from the north, turn in the west. When they write south, maybe 45 west, it means start from the south, measure 45 degrees towards the west. When they write south, maybe 30 degrees, maybe east, it means start from the south, measure 30 degrees towards the east. So that is the meaning. And expect now such things because now they are going to be very important. Okay. Okay, I continue. Now, like I've told you that they are going to mix bearings is always mixed with time and timetables. And all these are senior one topics because these are the foundations. Now, always do not forget to remember that when you are dealing with the time, always look out for the easiest thing to deal with because I've seen questions whereby they have been giving you in minutes and they mix them with hours. So do not forget that in 1 hour, you have 60 minutes. This is now the basic that everyone needs to know. This is now the basic that you need to know that in 1 hour, I'll have 60 minutes. Then the other can come in. But at times, they can even confuse you. They can say 3/4 of an hour. Now, for you need to know that 3/4 of an hour will be 3/4 of an hour. But in 1 hour has how many minutes? Then you say 3/4 times the 60 minutes. And then you come up with your 45. So now you need to know that they can now use words in order for you to be confused. So now you need to know when they say half an hour, then you come and say half an hour. But what is an hour? An hour is 60 minutes. Then you deal with it. So this is really very important. They can mix the questions that say, the person took a half an hour to move from this point to this point. So if for you, you don't know how you are going to deal with it, then it may be very hard. And also when we are making conclusion, in questions where you have time, make sure that you put it in units that are easy to read. Take an example. You have made your calculations up to the end. Maybe you were calculating time and you got your answers 0.05 hours. Now, this one is not easy for someone to read. You put it in an easy way, in how you are, an easy way of communicating it to the person you are going to communicate it. So when you say that, when you tell the person that it took me 0.05 hours, someone will say, hey, what is that? Now here is where you need now to think critically and say, this is equivalent to 3 what? 3 minutes. So someone who has written 3 minutes, he has thought deeply compared to someone who has just stopped at 0.05 hours. Because in communication, it is always key to deliver the message effectively. So here, in case you find that your time is very, very small, convert it to the easier units that someone can easily read of. So 3 minutes would be okay. So in other words, you multiply these hours, the 0.05, then times the 60 minutes to convert them, other than you leaving. In case you find that telling seconds is okay, then you tell in seconds. But here, the best way to communicate in your conclusion is having hours and the minutes. So in case you get 2.05 hours, then here the best way is to write is you say 2 hours and 3 minutes. That is the best way now to communicate when you get 2.05 hours. So, right, because this is 2 hours plus 0.05 hours. So what are you going to do? You are going to convert this 0.05 hours back to the minutes. So that's how we say 2 hours and 3 minutes. Instead of you concluding like 2.05 hours. And this one is very common. Whenever after you have drawn, they may ask you, what time would that person have taken if he had used a direct route? And now you may find your calculation, you are getting something like that. Even if you calculate and maybe you get 1.084 hours, here still come and say this is 1 hour plus. Now here, since this is 1 hour, then these ones that are remaining, you say 0.084 hours. Then you convert these hours back to the minutes. So you say 0.084. If I convert it to minutes times 60, what do I get? Then you say it is equivalent to 1 hour and 5 minutes. Okay, so that one is very important. Then I've also noticed that because the question can also contain time, they may also tell you in what we call the 24-hour clock. So they may put for you a 24-hour clock. Please pay attention to it. You need to know something about the 24-hour clock because someone may just write it. And remember that when it comes to a 24-hour clock, remember someone may say, maybe the speaker started this journey at 2014 hours. He moved like this, like this. And now if you don't know 2014 hours, you may ask yourself, what time is it? Now this one, it means that they have written in 24 hours. At times they can write 2014 or they can just write 20 and 14. Remember, when it comes to 24 hours, it is optional for you to put the semicolon. You can just write it as a one thing. Now, when you find that maybe the question, they have mixed some 24 hours, what do you need to know? That in order for you to make it easier for yourself, because we are used to the 12 o'clock hour, what you do, any hour you find that if you find that the hour is above what? Is above 12 for a 24-hour clock. Whenever the hours are above 12, let me say you find 13, you find 14, you find 15, 16, 17, 18, 19, 20, 21, 22, 23, like that. What do you do? Here, always subtract minus 12. So you just say, if you see, maybe they have given you 13 and 50. For you, what you do, the first two digits are the ones that are representing the hours. Then the next one are representing what? Minutes. So always for you, subtract 12 from the hours. So you just say 13 minus 12, which is 1. So that means it is 1 and 50. When you find 14, for you say 14 minus 12. In case you find 15, you say 15 minus 12, as long as the time they have given you is above 12. But in case you feel that one is a bit, you can come and do it what? Manually. You can come and, because now remember you must look for an is a load. So what you can do, remember, you can say this is 12. Remember, 12 remains 12. So you can say this is 13, this one is 14, this is what? This is like 15, this is 16, this is 17, this is 18, this is 19, this is 20, this is 21, 22, 23, and then 12, or like what we call 00. So for you can come on your clock, you draw it, and then for you can say that if it is 13, it means it is 1. If it is 14, it means it is 2. If it is 15, it is equivalent to 3. In case it is 16, it is equivalent to what? To 4. So for you can come on your clock, you draw it in case you have forgotten. But remember, the minutes remain the same. They do not change. But the only thing that changes are the hours. The rest of the things remain the same. So that one is really very, very important. Now, take note. If the hours are less than 10, simply just put an AM. If the hours are less than, whenever they use a 10, whenever they use, let me say, in case they're using a 24-hour clock, and you just find 0814. Here the hours are less than. So this is the same as having 8:14 AM. So for hours that are less than 10, it means that is AM. Hours that are more than, that are beyond 10, it means it is PM. So PM, those are the hours that are above, above. Take an example, you find 13. So 13, it means that is PM, 1 PM. 14 means 2 PM. 15 means 3 PM. 16 means 4 PM. So hours that are above are 10, those are the PM. Sorry, yes, those are the PM. Hours that are less than 10, those are the AM. Hope I have answered. So in case for it, you find it in 24-hour clock, please take note. Let me say they write this in, like when they write something, they say 036 hours. Now for this one, since the first one I've told you these are hours, these are minutes, then the next ones will be seconds. So when you find it like this, for you don't need to do anything. You just say this is 6 AM. If you find maybe they have put 09, maybe 40. So this is 0940 AM. So the AMs remain the same like the way we have it in the 12 o'clock. Hope I have answered. I saw that question in the chat. Okay. 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 I think let me hope that is now clear. Yes, let me pick, yes, Chidabo and someone who is raising up the hand.
Good morning, teacher.
Yes, good morning.
I think it's supposed to be if it's more than 11, not more than 10, because 11 o'clock is still in the morning.
Yes, okay. True. Okay. So I think we can proceed. So, but you need to know that when it comes to 12 o'clock, 11 AM, we'll stop at what? 11, 59 around there. Then when it comes to 12 PM, then that one means it is 12 PM. It means when it comes to noon, anyway, noon, it means that is the PM. But please do not forget to always subtract. If you don't know, you can do it the other manual way. Okay. Now that one, I think we have completed. Now, what are the focal areas, or which areas do they look out for when it comes to the bearings? Now, when it comes to bearings, I want us to pay attention. Those are the things they are going to look out for when they are marking your work. One, they are going to look at the compass. So make sure that when you are drawing your compass, you draw your compass very well, and then always indicate that this is the north. Hope that is okay. When it comes, so always indicate your north. For any compass you draw for your bearings, whether you are drawing a sketch, whether you are drawing an accurate diagram, always indicate the north, and always show that cardinal point, the arrow, that it is pointing north. Number 2 is the distance with correct units. When you are drawing your diagrams, let me say you have drawn this, you have drawn this. Don't just write here 10, and then for you continue, this is 5. No. Write the correct distance with the units, that these are centimeters, these are what? Are centimeters. 3, the scale conversion. Some of you are really very smart. Take an example, you may find that they have given you 100 kilometers. For you, you use your scale in your head and you say, I'll use 1 maybe centimeter to represent 10 kilometers, something like that. Then for you come on your diagram, you just put 10, you put 5 from nowhere. Then for such, you need now to be very careful. Why? Because you are going to miss out the marks for converting of the scales. Each of the things I'm mentioning here, it is carrying a mark. So, meaning that if you don't show how you converted your scale, then it means you're going to miss out on those marks. So you must clearly state that my 1 centimeter represents 10 kilometers. So that is the scale conversion. And show clearly that here, the distance from A to B, the distance from this, and show how you are converting those different scales. Okay. Okay, okay. Then the next one is the sketch drawing. Always have a sketch. Don't start from the actual diagram. Even if you have been caught up with time, make sure you have a simple sketch. And being a sketch, it doesn't mean that you are going to do rough work. No, I saw kids during mocks who are using freehand. No, use your compass, do a simple sketch. But when it comes to the sketch, extract the information exactly the way it is in the scenario. So for sketch, we expect you, in case it is 100 kilometers, put it there. 50 kilometers, put it there, and the rest. But then up here, I told you having a title is crucial. Say a sketch showing, maybe the journey of someone, and then show it clearly. But do not forget, because a sketch, let me say it is being given 2 scores. Now, there's things that they are going to consider. One, they may look at one, does she have the compass points? Yes. Then, remember I've told you, has she indicated the angles, that this angle here was maybe 120. This angle here maybe was maybe 30. Remember, in bearings, the 2 important things are angles is the first one, is the most important one. And after angles, you bring the direction. So now I will look out for the angles. Are angles indicated? That yes. What about the direction? Now the direction, I'll look at the arrows. Now that one is what makes a good sketch, that you have the angles indicated and you have the direction. So if you don't have those two, then it means there is a problem. You may even not score anything, because if you have ever gotten a 0 on the sketch, it is because you missed out the arrows that show the direction, how you were moving or how the person was moving, and you didn't indicate the angles. Then a title is very key. For any graph you are drawing, kindly indicate the arrows, indicate the title for that particular graph. Okay, then accuracy, distance and angles. Now, when you are measuring, please, you must write to at most 1 decimal place. The measuring instruments you are using, your ruler, the protractor, you can only measure to 1 decimal place. So we don't expect you to take any measurement. Let me say they have told you the direct road and you write your answer as 12.45 centimeters. This one cannot happen. You write your angle and you write 30.45 degrees. This one can't happen. So the biggest decimal point you can write should be to 1. Either it can be 30.5 degrees, or in fact, even 30.5 degrees, it might be hard for you to achieve. That's why now, in fact, I can say when it comes to angles specifically, write to 0 decimal point. For angles, for distance, write to 1 decimal place at most. For angles, at worst, I know you can get it when, and for you, sit is somewhere, not touching. So for angles, you can read to 0 decimal place. But for distance, you can read to at most 1 decimal place. Then the conclusion. For all these bearings, you must have your conclusion well stated. And in your conclusion, you must convert back to the original units. In case they ask you for the distance, then make sure that in case you got you have measured, you have got 12.4 centimeters, then even you must show that now, since I said 1 centimeter is this, then I must be able to convert back. Yes. Okay, that one is very, very okay. And please do not forget that also we can combine. It can be combined. Bearings can as well be combined with trigonometry. More so if at all we are interested in calculation. And the moment you see trigonometry being merged with the trigonometry, it shows you that now the sine rule and the cosine rule must be at your fingertips. Yes, but now I want you to know that in the new curriculum, we are mainly looking at the applications, real life applications. Okay, now, okay, let me first clean this. Okay, now I come to the way you are placing your protractors. Now, When you look at let me put letters and I check out. This is our A, this is B, and this is C. I want you to tell me in the chat the correct ways of placing the protractors. You just say A, B, or C. It is up to you. So place in the chat. I want to see whether people know how to place the protractors. Okay. Yeah, okay. Now I've seen. Now, please, the only correct ways of placing the protractor is A and B. C is totally wrong. C is totally wrong. Never and never place your protractor like this when it comes to bearing. The only possible ways of placing your calculator is either A or B. And under what conditions do we place under A? Under A, it is when you have your compass. Let me say this is your compass, like that, and like this. Hope that is okay. If that is how your compass is, like that, that's how you place. And that is when you are measuring an angle. Let me say you are measuring 120. So I've told you we use the outside scale. So this is where 120 is. So you'll come and you draw your thing like that. So that is how you place it. In case maybe you are measuring from south and going this side, still, and you want maybe 45, still you place it in this format. And then you count that 45 will end here. Or alternatively, if you are measuring angles that are above 180, then still you place your protractor like that. So here you measure, it depends. In case maybe they have told you from south, turn to west 45 degrees. Then I'll come and I say 45 degrees is here. So meaning I'll turn like this. I'll turn like this. And this is where we have our 45 degrees, the bearing. This is 40, 45, like that. So you can either, it is only these two positions. Please never place it like that. Many of you who have been failing bearings, it is because you place your compass, your protractor like that. So you cannot measure your angle and you come and you place it like this and you measure that I'm measuring 40. No, this is totally wrong. So from today onwards, make sure that this is how you place your protractor in order for you to be able to get the results. Okay, let me hope that is okay. Maybe there are few cases where you can place it like this, and those are cases maybe when after drawing, and maybe you have your thing here, and you want to find out to discuss small angle. That one is okay to find it, if at all you're placing it here. But if you're measuring those measure angles, then please place it either in position A or in position B is. And for this one, it is that condition whereby you are measuring this. That's how you can place it like that. But please be very careful when it comes to placing your protractors. Otherwise, you can fail the whole number because of, I've seen, even in mocks, I saw, I think it was it Croatia, something like that, where I saw children failing because they failed to place their protractors correctly. Now, when it comes to drawing your diagrams, we always draw them on a graph. When you are making your accurate diagram, I would advise always draw it on a graph paper. The UNEB graph papers are standard graph papers and have correct units of measurements. Their 1 centimeter is standard. However, your rulers that you have, at times they cheat you that it is not exactly 1 centimeters. And that is the reason why at times we fail to get the same results because our rulers at times are different. So when you are making your actual diagram, that accurate diagram, draw it on the UNEB graph paper. However, I want you always to trace out, when you are drawing your first compass, I want you always to trace out these borderlines you are not seeing. These borderlines here. Trace them. That's where you're going to draw your compass. There is no need for you to construct. Come, look out for this borderline here. Trace it very well. trace it like that. And then you draw your compass very well. Don't trace these small ones. Like some of you are funny. At times you can find someone coming and drawing something like that. Please, this one you cannot be accurate. Your first compass, let it trace out that borderline, any of those borderlines that you have on your graph. It can even be this borderline here. It is very okay. Trace out that line for your compass. And even for the compass, it can be, don't draw, let this vertical one not be more than 4 centimeters. Let it not be more than 4 centimeters. Let it be below 4 centimeters and not 2 centimeters. At least let it be 4, 2 is okay, 3, but not 1 centimeters of height. Yes, in it.
Good morning, teacher.
Yes, good morning.
Teacher, my question is that should the sketch also be on the graph?
Not really. A sketch can be in your answer booklet, but if you can have both of them on the graph. One up and then the accurate one down. Then here, like I advised, when you are drawing your diagram, it is okay to use a pen as long as you are very accurate. As long as you are very accurate. And at this in this generation, I have seen pens that have these erasers. So when you are going back for third term, you can get that pen. I don't know how much it costs, but in case you have ever bought that pen that has a rubber on it, you can put such that you can look for it, such that when you are going back, you have it. Why? Because it is very easy. Your work becomes easy to mark when you have used the pen. Because imagine you have used your pencil and your work is faint. And these people at times they have those eye challenges, so they may not see your work clearly. But everything is being they can mark it as long as it is okay. But if you are not an accurate person, please stick to stick to using a pencil in case you are not accurate. But if you have practiced enough, then it will be very good for you. So still here, when you are measuring your angles, I would expect that you are going to place your protractor like this, use the outer side scale, and then measure off lightly. And I want to let you know that for your neb, now like this graph I'm using, this is a standard graph. This is 1 centimeter. So if you are going for these numbers, test out your ruler, whether it is an accurate ruler. So for you, put one box of that graph for your neighbor and see whether you are getting that 1 centimeter. If you find that it is 1 centimeter, know your ruler is accurate. If you find that your ruler that you are using is stopping somewhere here, please look out for another ruler. Ask the person in the room that, may I have another ruler from my friend? That means that your ruler is not accurate, meaning that any other thing you are going to be calculating or doing is going to be wrong. So first check out your ruler, whether when you measure it here from one point to another using that standard thing, that your ruler is also 1 centimeter, that they correlate. In case they don't correlate and your ruler is a bit small, ask for another ruler such that you don't get, because the moment you start measuring these distances and your ruler has wrong measurements, then it means that you are going to be getting wrong things. So at the end of the day, your answers are going to be diverting from the correct answers. Okay. Yes. So you are going to take note of those. Correct reference points, accuracy, direction, format, and the rest of that. So you will take note of that, clarity in diagrams and use of the scale very well. So now we are going to start. Seeing a hand up. Yes, Tekino and Katas.
Good morning, teacher.
Good morning.
Yeah, since you said that at times the graph paper can have measurements that are less than 1 centimeter.
Your ruler, not the graphs.
Yes, I'm saying. You see, at times we got graph papers some time back, and they were not accurate. So is it correct if I take my own measurements from the ruler?
Perfect, yes. Yes,
And
now, so Evelyn, that is the best.
Okay.
That is the best. Yeah, in fact, now, we are going to note that these graph papers you buy from supermarket, you buy from where? Those people didn't, for them, they are about money-minded. So they don't do things accurately. So the only graph that is standard is the UNEB graph paper. Those graph papers you find with the UNEB things, those ones are standard. The ones you are going to use in your books are standard. For them, they are measured correctly, and they are the same throughout the whole country. For UNEB, but these ones you buy, these ones you have in your small books, those ones in most cases, they are not accurate at all. So for those ones, in case those are the ones you're using, please measure them. Yes, Samsung.
Yes, sir, good morning.
Morning.
Sir, is it a must that maybe your drawing should be done in graph paper? Is it a must?
Yes. Yes. Why?
So,
In fact,
how many graph papers maybe are provided to each learner maybe during examination?
any you want, because they give schools as many graphs as they want. So for you, ask as many as you want. Even if they are 10, they will give them to you.
Okay, thank you.
Thank you. Okay. Now, why am I saying that use a graph? Because when it comes to many of you, when you are using your plain paper, those papers, many times you draw these, you draw your compasses when they are not straight, when they are not 90 degrees. So that's why I'm saying, but when you're using a graph, your compass is really at 90. That is the best thing. But here, when you're drawing on your ruler, you may draw something like this and it's slanting, and you end up measuring wrongly. So I advise anything, in fact, anything concerning graphing, anything that involves you making a sketch or what, put it on a graph paper. Don't put it anywhere else. Put it on a graph paper. In fact, if I told you draw your work on a paper and not a graph paper, I may not mark it at all. Yes, because I know you cannot be accurate at all. Okay, now we are going to start on this number. We are going to do about 3 activities concerning the bearings. Now, when you look at the question, they are telling us that the Speaker of Parliament left Kampala at 10 a.m. Now here, they have given us in a 12-hour o'clock. So another time, you may find them giving you like this. So that one is okay. But we have said that if it is about 10, this one is the same thing. So that one you don't need to worry. You just report that is AM. And she normally drives her car at an average speed of 80 kilometers per hour. She traveled by road from Kampala to Bulamuti in Kamuli district. The speaker moved from Kampala on a bearing of 060 degrees. Like I've told that the moment you find 060 degrees, it means that is the north. Now, what are you going to do? I'm going to first write a sketch diagram showing the speaker's journey. If you want, you can say, it depends on the time. You can say from Kampala to Bulamuti. Then you are going to come for a sketch. I've said you can draw it on your paper or you can put it on a graph paper. Then I'll come and I say, this is my compass. On my compass, clearly indicate that this is your north. Then they told that she traveled by road from Kampala. So you are going to come here and say Kampala. Indicate the place, please. Don't use abbreviations. K, M, what? 060 degrees. Now I'm going to come here from the north line. I will measure 60 degrees. So remember, for sketch, you don't need. So that means 060 means that from the north, turn 60 degrees. So I'm going to come here and I will come here and I put 060 degrees. And they told us to move from Kampala on a bearing of this to Kayunga. Now you are going to come here and say, now here where the speaker is, it's going to be Kayunga. You come here again, indicate that this is north. And where is the speaker now? This is at where we have what? Kayunga. Then what is the distance from Kampala to Kayunga? They're telling you it is 80 kilometers away. So you come here and say 80 kilometers. She altered is like she changed her direction and traveled to Busana 40 kilometers away on a bearing of 110 degrees. Now, still, it means that where the speaker is, you place your protractor like this, and then you measure off 110. We use the outer side scale, so 110 maybe it can be here. So you draw your line very well. Now, after drawing your line, you come, you draw your compass. Then place here this direction that the speaker turned. Let me first remove this. I remove this. So come here, the direction the speaker has turned here. Indicate that this is 110 degrees. Now, after indicating, in fact, if you want, you can even put the arrow. You can put the arrow that is how I'm going to turn. Then come here, say, she altered, which is 40 kilometers. Then put here 40 kilometers. Then you continue. However, for any step you are taking, do not forget we said that for bearings, what is important? Angle and direction. What is going to show us the direction is you putting an arrow. So don't forget, put an arrow to show how the speaker is moving. Then they told us now, where is the speaker? The speaker is where? Busana. So you put here that this is Busana. Now, afterwards, they told us that from Busana, she used a ferry and later on a car in the direction of northeast. Now, northeast means that you must know your compass because now there they have not given. This is north and this is where we have our east. So meaning that from north, you turn to the east. So what is northeast? Northeast is between the north and the east. So it is in between here. And since this is 90 degrees, it means that the northeast is being divided into 2. So 90 divided by 2 is 45. So here you have 45. So instead of being told that the angle is 0.45 degrees, now they have mixed with words. So you come here, measure off, put here that this is my north, and come and put here and turn here 0.45 degrees. And this is now the direction the speaker is taking. And they have told you that now she has reached Bulambuti. So I'll come and I say, now the speaker is at Bulambuti, which is 20 kilometers. So I'll come here. I say this is still my north. And I say, this is where I have Bulambuti. Now, after that, you continue. On reaching Bulambuti at 2 p.m., the speaker remembered that there is a direct route from Kampala to Bulambuti that she could have used, but she doesn't know how long it is. Now, since they have told you the direct route, I'm going to come here and I say direct route. Because this is Kampala and this is Bulambuti, it means that my direct route, I'm going to join from Kampala to Bulambuti. I can use dotted lines like that, like that, like that, like that. Then I will say, this is the direct route. So anything that you are going to draw on your accurate diagram, also indicate it here on your sketch. Now, this is now a sample of my sketch that I'm going to draw. I'm seeing some hands up. Okay. Yes, Chidabo.
So in the beginning, we had like, when you're teaching us how to use the protractors, you gave us A and B. So apparently, when we're starting the sketch diagram, it told us Kampala, you use, is it a protractor B. Okay, something like, like protractor example B, right?
A protractor B.
No, protractor example B. In the beginning, you gave us those examples, A, B, and C, but you told us we use A and B. So for Kampala, you told us you're going to use protractor example B. I just wanted to know
what protractor B?
Protractor example.
Oh, here, you are going to use this one.
Oh, sorry, protractor example A. So I just want to know what should depend on to make the choice.
The choice. Now, are you looking like here, when I place my compass point here?
Yes.
Are you seeing that now, because they told you she turned what, 60, you'll notice that 60 is here.
Yes.
So that's what you look at. You look at how she's turning, that she's turning from north going east. So the 60 will be here. The 110 is going to be here. So for it still, you place it in the same way. 110.
Okay. Thank you.
Okay. Okay. Bogele.
Good morning, sir.
Morning.
When you said that we should use a graph paper, but for me, I have discovered that when we use a graph paper, you can measure a distance. When that distance ends on where it ends it is not a bold line. Now what should I do when I meet that circumstance?
Oh, see, for you where you have stopped is where you stop and use it, even if it is not stopping at the borderline. I said.
Yes. Okay, you said that when we are starting.
Hey, that's where you trace the borderline. But for other parts, it may not lie in the borderline. But the first compass you draw is what I'm saying.
No, can't it confuse me?
Can't it confuse you? No,
yes.
Because like I've said, it will be very accurate. But I'm going to show you. I have a case of that nature, how to deal with it.
Okay, sir.
Yes, even if Grace, even if this is your graph, and maybe it your thing you measure and it's stopping here, you will know that I'm going to draw here in between, and also I can draw here. In case it is here, you will know that I will draw here and here. So that's how we draw it.
Okay, sir.
Because there, at least you are sure that you are going to be very careful that your line at least is straight. Even if you make a small error, it will not divert. Compared to someone who has used the plain paper, for it, he can easily divert very far away.
Okay, sir.
Okay, Blessing.
Good morning, everyone. Good morning, sir. So for us, we had a scenario. So this scenario had both clothing. It had what we are doing, but at the same time, it had like business maths. But the question, they mentioned 3 sides. But when we did it with that teacher, we had like only 2 sides. They were like, she was on like landing site A, and then they gave us the coordinates. Then they told us she went to the southeast of land site 0 over O, I don't know. Then she went to B, but at A she spent 3 hours. At B she spent 4 hours, and she started her journey at 10, and she hopes to go back where she started from. Actually, at her home. Yeah, she hopes to go back in 20 hours. How do I find the time that she went back?
Okay.
If I don't know the time she traveled.
Okay. We are going to handle it. If you can share the question, but also I'm going to bring to your attention that sometimes the scenarios being set, some of them are not proved. So you may find that they have some errors.
Okay.
Yes. But if you have the question, you can send and I review it.
Okay, sir.
Okay. Okay. Let us first complete. I'll answer the questions. Yes. Now, after that, so this is your sketch. Now, after finishing your sketch, you'll have gotten your marks here. So you can either have 3, all the 3, or you can have 1, depending. But please indicate everything very well. Now, after that, the next thing you do after the sketch is the scale. Now, here they don't give you a scale, meaning that you must look out for your own scale. Now, what do I recommend? avoid a scale that is going to give you very small distances of measurements. Take an example for this particular one. Avoid having a scale whereby, let me say, someone say, let 1 centimeter represent maybe 40 kilometers. When you use such a scale, you're going to find that your graph is going to be very tiny. Now, always reason out that which scale is good. And now I want you always to check out the best scales still, even when it comes to math. The best scales will be those ones that end with. Take an example. 1 is good, 5 is good, 10 is good, 50 is good, 100 is good, 500 is good. So when you are looking through, first check out any of these ones: 110, 100, 550, or 500. Because you may have a case whereby you say 1 centimeter is equivalent to 1 kilometer. Because they can give you small distances: 8 kilometers, 4 kilometers, 2 kilometers. For that one, this one is good. They can give you a case whereby they are very small. So for that one, use it. So please be very, very careful. Yes. Now for this particular one, I want to see members in the chat indicate among these one, which one do you think is very appropriate for us to use? 1, 10, 100, 5, or 50, 500? Indicate in the chat. As blessing, you ask.
Teacher, I have sent the question that I was mentioning. I have sent it.
Okay. So in the chat, I'm looking through the chat. Some people are saying 100, others are saying 5, others are saying 10. Okay. Now we are going to use both. We are going to use and we test ourselves and see. Take an example, someone who has said that for her, she will say 1 centimeter is representing 5 kilometers. Remember, when we are converting, we shall convert 80 kilometers. So you ask yourself, 80 divided by 5, how many centimeters are those that you are going to get? So 80 divided by 5, you'll end up with 16. This is very big. And in other words, take note, never have something beyond 12. That one is going to disturb you a lot. Anything beyond 12 will disturb you. So this one, 5, we shall disqualify it because it is already above 12. When you go to 100, ask yourself, when I say 80 out of 100, what do I get? I will get 0.8. This one, we shall disqualify it. Why? Anything below 1 is not easy for you to measure. So looking through the chart, the best that we can use is 10. So that is the best scale we can use now for this particular number. So what am I going to do? Indicate that, so I'm going to come here. Since now this one is okay, I'm going to come and I say that my 1 centimeter is going to represent 10 kilometers. That is your scale. Then afterwards, we are going to convert the 80 kilometers, the 40 kilometers, and the 20 kilometers to centimeters. So now, still you do it on your paper. So now you're going to say, conversion or converting the distances. Converting the distances. Why? Please, I want you to have your work to be coherent when it is flowing. Then you are going to say, the first one, Kampala to Kayunga. After indicating that my 1 centimeter will be representing 10 what? Kilometers. So you come, you say Kampala to Kayunga. What is the distance? The distance is 80. So you say 80 divided by 10, which will give me 8 centimeters. Then you go to another distance. The distance from Kayunga to, I think it was what? To Busana. And what was the distance? It was 40. So you say 40 out of 10, which will give you 4 centimeters. Then you go the distance from Busana to Bulamuti. What was it? It was 20 kilometers. So you say 20 divided by 10, which is equal to 2 centimeters. Those people who don't know, whenever you are converting from a kilometer to a centimeter, always you divide by that particular scale you have taken. So here you have finished to do the conversion. Hope we are together on that. Now, after doing that conversion, okay. Okay. So, okay, I was seeing someone. Yes, I want someone. There's someone who's telling us. Someone, I was looking through the chat and someone is saying the angle of Usana is not correct. I don't know why. Okay, but I think it is okay. I think the angle is okay. Kindly just check out. The angle is 45. Okay, now after that, we have finished to do the conversion. Now, after the conversion, this is where now we are going to go to our arcuate diagram. Now, when you are doing your arcuate diagram, you are going to go and write clearly. What are you going to say? You are going to go on your graph. This is our graph. And you write your title, your heading, that an arcuate diagram showing the speaker's journey from Kampala to Bulamuti. That is your heading for the title. For the what? On the graph. Then I will come, allow me to first remove this now. Yes, so I will say an arcuate diagram. Please indicate that this is the arcuate diagram. You say an arcuate or arcuate diagram showing the speaker showing the speaker's journey from Kampala to Bulamuti. That is what you do. Then indicate here, put your scale here on your graph because they may not see it the other side where you have written it. Put it here that 1 centimeter is representing or represents 10 kilometers. Then now come on your graph. Like we have said that on your graph, I have said I advise you trace out these ones. Are you seeing that one? Trace it out. And for this line, it can be 4 centimeters. It can be 4 centimeters. Such that you know that I'm going, the 4 centimeters, I'll come here and I divide it into 2. I have 2 up and 2 down. Then afterwards, I'm going to indicate that this is where I have my north. After indicating your north, we are going to put our protractor as usual. So I'll come, I put my protractor in this format. Then I use the outer side scale. Now, remember, this is now our protractor. Oh, where? This is our protractor here. So I place it and then I look out for 60 outside here. Then I say, this is where my 60 is. So may I ask you now, everyone, to first let us try out an arcuate diagram. Let's use 5 minutes quickly and see whether we can do it. So we have said where there is 80, we have said 80 has converted to 8 centimeters. So that is equivalent to 8 centimeters. So here, let me put in blue that this is 8 centimeters. 40 has converted to 4 centimeters. 20 has converted to 2 centimeters. So I want you now, let us draw the arcuate diagram in our books or in our graph. In case you don't have a graph paper now, kindly use your book. Let's do it. I think we can do it within 5 minutes. Yes, but let me ask MUM, kindly unmute. MUM, Mumu, unmute if you can. Okay, but let me hope Mum, you have seen that the angle actually is It's not 110. The 110 is Kayunga because they told that she traveled to Usana 40 on a bearing of 110. Okay, so we are drawing everyone. We are going to compare our answers at the end. Yes, Neish.
Good morning, sir.
Good morning.
Master, like,
Yes.
can someone use a compass to construct those the 90 the angle?
Okay, now I would advise that when you use a compass, it's going to take you a lot of time and you are going to be wasting a lot of time.
Right.
Because
But
by the time you draw
But if someone uses it, it's correct.
Yeah, it is okay. But remember, you must plan for your time well.
Right.
But it is okay. It is very fine.
Okay.
Yes, 11.
Good morning, sir.
Good morning.
Sir, I would like to know on how do we position our graph? Like, where do we put the starting point? Because sometimes when you start in the middle, you'll find yourself when the graph is not fitting.
Oh, okay. Now, basing on your sketch, the sketch will show you that my graph is mainly moving towards the right. So for such a case, what you do, you place, when you come to your graph, now like this is my graph. If you notice that your graph is moving towards the right, then you can leave just 1 centimeter this side and start your graph from here.
Okay.
So always look at where your sketch is moving. Is it moving to the right? Is it moving to the left? But still also check if it is going down, then it means that start above the middle. If you notice that it is having things that are going down, then start above the middle.
Okay,
such
sir.
that you leave that space that is going down.
Okay, one more question.
Yes.
Sir, can I please share one of the numbers they gave us during our mocks?
Yes, you can share them. I don't know if you can. Let me see where I can ask. You can share them. We shall summarize them at the end.
Yeah, it's only one number.
Yes, share it in the chat. I'll look there and then we download them.
Okay, sir.
Okay, so we are drawing our accurate diagram, everyone. So let's be drawing as I attempt some questions. And remember, for this number now we are planning. It shouldn't take you more than 10 minutes drawing just after coming up with your sketch. Yes, 11.
I think I've sent it in the chat.
Okay. I'm going to look there. Sobe Madrin.
Good morning, teacher.
Good morning.
Teacher, I beg your pardon on time.
Time?
Yes.
Oh, kindly. First, let me know exactly where, about.
Teacher, I came late, so I didn't get what you said about time. You are like, when you get 12-hour clock, you should change it to 24. Is it so?
Oh, no, like I was saying, in case they give you in 24-hour clock,
Yes.
Then, like the time that is easier for us to work with is 12-hour. So you change it to 12-hour for easy calculations and subtraction. Because they can mix 24 and 12. And we say that for 12, when it comes to 24, then check out in case maybe you find that they are, because for it they can say 20 hours, even if you have had president communicating. In most cases, he uses 24. So when you find him saying 20, it means that is 8. So when it comes to those 24-hour things, it means that you subtract 12. If the number is greater than 12. When you find that the time is greater than 12, let me say you have found 13, 14, 15, 16, 17, 18. You subtract the hours. In case maybe they have given you 15, 30. Here, you look, the first 2 digits represents the hours, and then these ones represents the minutes. So you just subtract 15 minus 12, that is what? 3. Then you say, this is 3, 30. And that is the PM. Anything beyond, anything that is beyond 12, anything beyond 12 is always the PM. Anything below 12 is AM. Is that okay? Madrin, hope it is fine. Okay. Vincent?
Good morning, sir.
Good morning.
So I'd like to ask a question still about time. There are situations whereby we find the question when they want us to get like, we first get the LCM, like the nurse visited the patient at this time and doctor visited the patient at this time. And we get the LCM when it is beyond 24 hours, like when it is in 30. What do we do?
Now, I beg your pardon, first come again.
There are situations whereby they bring questions like the doctor visited the patient at this time, the nurse visited the patient at this time, and they would like to meet again. When you get the LCM, we get the LCM like when it is after 30 hours. What do we do specifically?
Now, when you are working, okay, that is number one. You are number one. We are going to deal with number one next week. But when you are finding LCM, make sure you work in the same units. In the same units. Take an example. You can convert all those hours to minutes. And for you, decide to work with minutes. Then after working with minutes, you convert them to hours.
Yes, sir.
But make sure you work. In case you are working with minutes, work with minutes only. But I want to advise that now for such cases whereby you are going to find yourself having 2 and 5 minutes, something of this nature. Here, if you convert the 5 minutes to hours, LCM is going to be hard for you to obtain. So I advise that now the easiest thing is convert everything to minutes, and then you get your LCM in minutes. After that, convert it to hours.
Okay, sir. Thank you.
Okay. So let me hope we are sketching. In case you finish, you let me know before I take you to the articulate diagram. I want us to first sketch and try out on our own. And we are timing because I've told it shouldn't take you more than 10 minutes. Yes. Okay. I think this was who? Blessing. Blessing, I'm seeing the question you sent. They gave you the starting time. They told you the person would start at 10 a.m. and then come back at 20 hours. So Blessing, you have the time that the person is going to start the journey at 10 a.m. and they're hoping that she'll be back by 20 hours or by 8 p.m. So Blessing, you can let me know. I think that was Blessing. Whether okay. Looking through the chat, I'm not seeing
Teacher.
Okay. Yes.
About the number that I sent. We have that time she spent at the islands, but we don't have the time she was using to travel. So how do I find that time that she was using to travel?
Oh, okay. Now, distance is given by speed times time, not so?
Yes.
And according to the question, I'm saying that he used an average speed of about, is it 60 kilometers?
Yes, teacher.
So now you use that formula that distance is speed times time. So you get that distance is equal to speed times time. Then in order for you to get the time, you will say distance out of speed. Because that when they say on average, that is the distance, meaning that it was almost constant for everything he was doing.
Sir, no, the thing is, we have like 3 hours, then we have like 4 hours at a different point, then we don't know the time she used to reach her home. So my question is, do I get like the speed that I have, the 60, and any of the hours to get that distance between?
Okay, I think I need to read again through the question. I've just gone through it, but later I will do it at the end. Okay, let's
Okay,
first complete.
yeah. So then on the question that the last speaker had mentioned, the one where you can get like 30 hours, can't you just convert the 30 hours and be like 1 day and like the hours that fall in? But then my question is, how do you get that time that is in that other next day?
Now, in case the question is talking about hours, it is okay. Because now, like, you know that in a day has 24 hours. So
Yes,
in case it is 30, you say 30 minus the 24 hours. How many hours do you remain with? Those are?
6.
6 hours. So there, it depends on the context the question is. You can say it is maybe the nurse will return after 1 day, after 1 day, and then the other day will be like 6 hours in the next day. But it depends on how, something like that.
Thank you, sir.
Okay. Now, let me hope everyone has now drawn the accurate diagram. Now, I expect your accurate diagram to look like that. This is how I expect your accurate diagram to look like. This is mine. Now, when you look at mine, I want you to check well that I have indicated everything clearly. The only thing that I want now to put is to say that accurate diagram showing the speaker's journey from Kampala to Bulamuti. Then I'm going to go on and I say my scale, I can put it here somewhere, that my scale is 1 centimeter is representing or represents 10 kilometers. So here, do not forget there is north. So that is how your diagram should look like. If you have that, kind of indicate in the chat that yes, mine looks like exactly like yours. Let me see in the chat. That is good. People have it at least. Good. Now we start. Now the question wanted us to find out the distance, the direct route from Kampala to Bulamuti. According to what I have, yes, no, I know if each one of you might have this, but looking, oh, yes, Colin is, I advise that we can do in pen, we can do in pen and we can practice, Now, the distance from Kampala to Bulamuti, kindly measure using your ruler. What are you getting? Indicate in the chat, what are we getting for that bearing? What are we getting? 12.8, 12.8, 12.8, 12.8, 12.7, 12.9, Now, according to what I have, I got 12.8. So those who are getting 12.8 centimeters, we are together. Now, what do you do? When you look at the graph, they also asked the bearing of Bulamuti from Kampala. The bearing of Bulamuti from Kampala. When they say from Kampala, meaning that your campus is going to be at Kampala, from Kampala. So I'm going to come here on my diagram here. And then I'm going to indicate here. I wanted to indicate when we are seeing. I put an arrow here. So meaning that I'm going to look out for this direction here. So I will place my compass here I will place my protractor here, and then I measure off which angle do I have up to this point. Kindly let me know. You measure yours. Measure yours, and you let me know which angle do you have. May I have some angle? I want to check out what do you have as your angle. Let me see. There's something I wanted. Now, let me see whether I can pick this protractor. And I place it here for accurate measurements. Oh, okay, it has a bug. Oh, okay. Yes, so put your protractor and place your answer, and we see 071, 072, 072. Very good. Yes, so we are very accurate. That is good. We are accurate. That is good. So also, according to what I have, is 072. Now, what are we going to like we must conclude very well. So we are going to go back to our question, and we say, how far is Bulamuti from Kampala using the direct road? So you will say that distance is equal to, you have got 12.8, then multiply it by 10, because we must conclude. So this one will give us 128 kilometers. Then you say that the distance from Bulamuti to Kampala from Kampala to Bulamuti is 128 kilometers. But the first one, remember, we have not answered the first one. Describe the direction of Kampala from Bulamuti. Now, when they tell you to describe the direction, what does it mean? It means that state the bearing. So here, you only state the bearing or the direction. So you will say, the bearing of Kampala, here the Kampala from Bulamuti. Describe the direction of Kampala from Bulamuti. Hope you are getting the difference. Okay. So, okay. So you describe the direction of Kampala from Bulamuti. I don't know whether you have seen it. So I don't know why people are getting here. They say the bearing of Kampala from Bulamuti. Kindly, if they say from Bulamuti, it means here we are going to stand where? At Bulamuti, and we get the Kampala on part 1. So I expect now, can we get that direction of Kampala from Bulamuti? That is the first one I want us to get. Can we get that one? The first one you gave me was from, the first one is from, the one you have given me is the one of Kampala, of Bulamuti from Kampala. Now, what about Bulamuti, Kampala? The bearing of Bulamuti from, I don't know whether you are seeing the question. The question wanted us to find describe the of Kampala from Bulamuti. So what is your direction? What is your direction? Southwest. People are saying southwest. When they tell you the bearing, kindly indicate the correct direction. Measure. Measure. Don't just give that one alone. So come here at this point. Are you seeing this angle here? Come here. Find out which angle do we have here, members. Find out which angle do you have here. Find which angle do we have there. Yes. As I indicate in the chat. Ruth is getting 252. Okay. People are getting 72 at that point. Oh. Okay. Okay. Looking through the chat, people are getting 73, 225. Okay. Now this angle, it is up. I don't know what you are getting. those who are getting 73, 75, within that range. Now what you do, people are getting 252, good. So here you'll say the angle is 252 degrees. So here when you are describing, you'll say that the bearing here on Roman 1, you need to be specific of the bearing. Don't say southwest, the way people are saying. You say the direction of Kampala from Blamuti is 252 degrees, or it is 255 degrees. The bearing of this to this is this. So that's how you conclude. Yes, those people who don't know how we have obtained, what we are saying is that here, first measure the angle you have here, which is 73. But remember, we said we always measure from the north, so we are interested in this angle. So even here on your campus, you are going to clearly show that this is the angle. So you will come and say 180 plus maybe 72. 180 plus 73. For you, what you are getting. Then after, get those degrees. Okay. Then 252, 250. Okay, that is the range. 253, 252. That is the range. Yes, Abby. Okay. When you go back to the question, yes.
I wanted to inquire that when you're writing on the accurate diagram, do you write the scale digits that you got, or you write the original thing in kilometers?
Now that is, I'm not seeing my diagram here. You write the converted scale, 8 centimeters, 4 centimeters. Never and never write here that this is 80 kilometers. Please, this is not realistic. In fact, if you find someone writing here 80 kilometers, here even someone has no time to look at your work. Because if you say 80 kilometers is from where your home is up to Jinja, even beyond that. So you ask yourself, is that distance really realistic? So please don't put the kilometers on your accurate diagram. The kilometers will always stop at the what? The sketch. Here, put in centimeters on any accurate diagram. In fact, if at all you are one of the, if at all I teach you and you write kilometers, I don't mark completely. I don't mark completely. Patricia. Okay. As we go to the next part, the next part wanted us. Yes.
Yes. Sorry. I want to ask, how did you get 045 degrees bearing from Busana to Bulamuti?
Here. Are you seeing this one? Northeast.
Northeast. Yes, teacher.
So we say that when you have your compass like this is north and this is east. How many degrees do we have from north to east? Patricia.
Teacher.
Yes?
90 degrees, teacher.
This is 90. This is 90. Northeast divides north and east into 2 equal parts. So when you divide 90 into 2 equal parts, you get so 90 divided by 2 is where we got our 45 degrees. Hope that is fine. Okay. Okay. Now the last part they're asking us that what time would it take the speaker to reach Blamuti if she had used the direct route? Now here you come back and remind yourself that the distance is always given by speed times the time. Now avoid abbreviating, you people. Avoid doing this. This one is mathematically not known anywhere. These are not standard what? Units. So don't use this. Write in words. Write in words. Then you say that since I want time, I'll say time is equal to distance out of the speed. Now looking through, they told that on average, she drives at 80 kilometers per hour. So meaning that now you're going to come here and say that now my distance is what? 128. That's what we got. Divide by the speed, which is 80. So this one will give us 128 out of 80, you'll end up with the 8 out of 5 hours. Now, I've told you that communication is key. Communication is key. Now, when you write 8 out of 5 hours, someone will be confused. What is this? Even when you are telling time, you cannot tell someone. They ask you, what time does she take? And you say 8 out of 5 hours. It really does not make a non-mathematician understand. So what do? You convert these hours you have obtained to the units that are easy to understand. Now, when you find you have fraction, the best thing first to do, first convert them to minutes. So you first ask yourself, 8 out of 5 hours is equivalent to 8 out of 5 times the 60. So you say 8 divided by 5 times 60. What do I get? That I end up with 96 minutes. Now, after getting the 96 minutes, you are going to ask yourself, 96 minutes is okay to conclude, but you ask yourself, could it be the best way to communicate time? No. Now, the best way to communicate, you say that in 96 minutes, how many hours and minutes do we have? Let me check now, people. Type in the chat. How will you conclude? How many hours and how many minutes do you have? Very good. So now your conclusion is going to be that it will take the speaker 1 hour and 36 minutes to reach Blambuti if she had used the direct route. Is that fine? Now, in your conclusion, they asked you, so now you have known that it is 1 hour and 36 minutes. But you have told it because they asked, what time would it take the speaker to reach? So that is the time. Now, next time, they may ask you, at what time would the speaker have reached? At what time would the speaker have reached Bulamut if he had used the direct route? Now, there you think quickly that they told you that his journey or the journey for the speaker starts at 10. Now, if they are specific, at what time would she have reached? Then you say, now, if she had started at 10, then you tell us that now I'll get the 10 a.m. plus the 1 hour and 36 minutes. So 10 plus the 1 hour and 36 minutes, it means that the speaker will reach at 11:36 a.m. Now, this question still, just because it was just in that way, it can even bring in the business aspect of math. They may ask you even to compare that if the speaker, if they may bring in the fuel aspect, that if the speaker spent maybe 40 or 50,000 on fuel, how much would he have spent if she had used? How much would she have saved if she had used the direct route? So we can easily combine it with the business math. Let me hope that is very fine. Hope that is very, very fine. Okay, but do not forget to conclude. Yes, Daniela. So that is how we attempt that number.
Yes, master.
Yes.
Master, do you still draw another diagram after doing the actual diagram to indicate the kilometers?
No, that is the sketch.
Yeah, now do you still do another one to indicate
Like
the kilometers?
when it comes to bearings, you must have two diagrams. You must have this one I have on the graph, and you must have this one, the sketch. Have the sketch and the accurate one.
Okay.
Now, members, do not forget, when they ask you, what is the direct route? Then please show the arrow.
Master.
Show the arrow moving from Kampala to Bulamuti for your direct route. If they had told you, the speaker came back from Bulamuti to Kampala, then make sure the arrow faces where it is supposed to face. Arrows are very important with the direction. Okay, now look at that number. Look at that number. Look at that number.
Mr. Faziba.
Yes.
Could you please go back to the graph?
To?
The graph. I wanted to ask, why is your arrow facing from Kampala to Bulamuti? Why is it facing that side? I thought.
Where?
The arrow, the direct route.
The direct route is like moving from Kampala to Bulamuti. Because they ask you, if the speaker had used the direct route, meaning that if she had gone straight from Kampala to Bulamuti.
Oh, so that's why our arrow is facing that side.
Yes.
Okay. Thank you.
Yes. Otherwise, if they were telling you that she's coming back, then the arrow would have faced differently.
Okay.
Okay. Okay. Now we are trying another one. I want you to read through this quickly and first come up with your sketch. Let's take some 2 minutes. Everyone come up with your sketch before we do it together as I answer a few questions. Marianne. Okay. I'm failing to get Tyra.
Sir, I was asking that, can you first write the degrees and then you write like southwest, like 60 degrees southwest?
60. Oh, now for the direction, Now for that direction, the alternative you could do, you could maybe say south 72 degrees west. If you want to write it in that way.
Okay, sir.
But the best direction, these ones are mainly used in navigations. So, but the best is you giving from the north up to where you have stopped.
Okay.
Okay, so everyone now is making a simple sketch. Ryan?
Good morning, sir.
Morning.
Sir, what I was asking on the previous question, how do you apply geometry?
Oh, geometry.
Yeah.
Okay. Now, if you want to apply geometry, you'd come, this was your sketch. Please remember, this is the sketch for the previous one, not this one. But that one is when they have asked you to apply geometry. So now, you know that this is 060. Now, this angle and this angle are alternating. So meaning that here you have also 60 degrees. Now here, you had 110. Now, 110, the degrees remaining here, you'll say 180 minus 110, which will be 70. So meaning that the whole of this angle here is going to be 60 plus 70, which is 130 degrees. Now, for this particular question, one of the things, like now here, you had, let me say 80 kilometers, 40 kilometers. In case they want you to use geometry, one of the things they can ask you is using geometry, what is the distance from maybe Kampala to Buthana? So for such a case, you just connect here and then you use your cosine rule. So you say that now here, in case it is A, you say A squared will equal to B squared plus C squared minus 2BC cos of the angle, which is 130. So that is the alternative when they want that. But for this particular one, it didn't want that. In case maybe, because what else can they can ask you for this one. So you connect directly here. But now for this one, you use the angle you have here. This one is the 45. The angle you have here, this angle here and the angle here are alternating. So this one is also 70. So you use this angle here and the distance you have here to get here. So that is how briefly you can use it. But here, there was no anywhere where you needed it. But it depends on what you want. But for those questions that always want you to use geometry, they will be specific and there is something specific they want. But for this one, the where you can apply geometry is finding the distance from Kampala to Bulamuti, finding from the distance from Kayunga to Bulamuti, like that, the direct distance.
Okay, thank you, sir.
Yeah, but those questions, I think I'll look for one and we try it out. Okay, let me hope everyone now has finished the sketch. Now we are going to start. Now, when we are starting our sketch, I know many of you have drawn. Yes, Brighton. Let me first pick these ones.
Excuse me, sir.
Yes.
I would like to know if we can draw the sketch and the accurate diagram on the graph paper at once.
Yes, it is very fine. Yes, the only problem you are going to have is having congested work on your graph. But it is very fine also. Francis?
Teacher, can you opt to use the plain paper for this number instead of using the graph paper?
I would advise Francis to complete the use of graph paper for accurate diagram. Like I've explained to you that when it comes to those plain papers, at times students fail to draw these straight lines very well. Someone may draw a line when it is slanting. Someone may draw when it is bending. So that's why we advise using the graph paper. But also, I want you to know that when we are drawing accurate diagrams, we are drawing what and the rest of that. Many times, many of those mathematical things, they are put on graph. In fact, in real life, when those people are going to go into navigation, those maps, even those maps you see, all of them, they are drawn on graphs. The only thing they do is that they remove that background such that you obtain what you have. But for accuracy purposes, they always put a graph paper. Those who know a bit of MATLAB and the rest of those programming languages, of those programs, you'll find that they have the graph there drawn, but now in case they are giving you a good picture, they remove the background of the graph of the square and they give you. Otherwise, it is always very hard for us to have something accurate. Even the maps, even these maps you are seeing, all of them are drawn on graphs, but they just remove the background. Okay, now let us first sketch this. Now, when you look at our sketch, here, this question is a mock paper. In fact, now what we are doing are mock numbers going forward. Anything we are going to be doing from here are mock papers. Now, they told us that Pamela is a business lady who collects merchandise from a certain town A to town D using a speedboat. Because of a very big island between the towns A and D, she cannot move directly to town D. She instead travels southeast. Now we are going to start. Draw your compass. Now this is our north, clearly indicate, and she's starting from where? Town A. However, they're telling southeast. So southeast, remember this is south and this is east. So southeast is between south and east. So I'll come here and I draw like this. Now, what do we know? That southeast is at 45 degrees from south and it is also 45 degrees from east. Now, what are you going to do? You always indicate this angle here. That bearing is what we are interested in. So what are you going to do? You are going to say that 45, because here you have 90, so I say 90 plus 45. So that angle is going to be 135 degrees. So that's what you indicate on your diagram. Then after, you are going to come, put the arrow. Travel south to town B at a speed of 40 kilometers per hour. Now, on our diagrams, we never indicate speed. We indicate always the distance. So you come and say, my distance is, now I say distance between A to B. So you say that we want distance. That distance is given by speed times the time. So what is your speed? Your speed is she's using 40 kilometers and the time is 5. So here our distance is going to be, is it 200? 550 times 4. I think that is 200. So you have your distance as 200 kilometers. I don't know whether that is very okay. Kindly let me know whether that is very okay. Is that fine? I don't know whether we are together. So then you continue. 40 times 5, you get that 200 I'm talking about. Then after that, so these are 200 what? Kilometers. So it'll come here and you put 200 kilometers. Now, after putting the 200 kilometers, you are going to continue and move and ask yourself what it is, where it is are we going? Now you say, you are going to come here, draw your compass. This is still the north. Then come ask yourself, for 5 hours. From town B, she moves at a speed of 50 kilometers due east. Due east means that she's moving the east. So when she reaches here, she's going to move like that, east. That is the east. Remember, this is where our town B is. Now, this is the direction she's going to take. But they are telling you, now here you say, distance between B and, this is what? Distance between B and C. Now you come and say, what is the speed that she's using? She's using 50 kilometers. And how long has she traveled up to C? It is 8. So I'll say here, distance is speed times time. Then I say, this is 8 times the 50. So you say 8 times 50, and you end up with your answers, 400 kilometers. So here I'm going to put 400 kilometers. Now, after putting the 400 kilometers, you are going to continue. You are going to continue and ask yourself the next statement. She then maintains. Now, that's where we needed to understand a lot. That's where we needed to understand a lot. That she then maintains this speed for another 6 hours, having turned through 120 degrees to the left. Now, that is the most important. I'm back, sorry. Okay, now there's, okay. Okay, I hope you can hear me now, sorry. Okay, now from there, we are here. She then maintains this speed for another 6 hours, having turned through 120 degrees to the left. Now, that statement was very, very important. Yes, it was very important. And that is where many children went off. It seemed to be a very easy number. Now, what does it mean? That this person initially was moving like this, like this. Then she turned on left 120 degrees. So I want people to tell me, is this person going to turn like this? That is A. Or the person is turning this. So tell me in the chat, is it A or B? Where are we going to move? A or B? Okay. So, yes. Now, where is your left? You ask yourself, when someone is moving like this, where is your left? Is your left on A or B? Ask yourself, when you are moving like this is your car. You are moving like this. Is your left this side or this side? So that is what you needed. So, very good. Now you have understood, members. So when she reached that point, that's where she turned to the left at the same speed. You know those people who drive like mad people, they drive very fast. So meaning that if this is where point C is, this is point C. When she reached here, she turned what? So for you, just place C. She turned 120. So 120 is going to be a distance somewhere here. Members, let me through the chart, whether you have understood that concept. Is that part okay? How I'm placing the 120? Very good, very good. Yes. So that was the most confusing statement. So I want you to take note that when they say she turned left, remember you are going, you are moving initially, you are going like this. You are moving, and you turn suddenly on left. So here, when you are measuring, I don't want you to confuse it and you say, at C, I'm going to draw my compass, then I measure 120 towards the left. No. Here, it means that this is the direction he was taking at first, then she turned that direction. Okay, that was what was very important for that particular number. Yes, Daniela and Akram, I don't know whether you have a question.
Teacher, how have you placed your protractor to get the 120 to get
Which
the
one?
angle? The angle from C. It's not the way you told us to place the protractor.
Oh, I'm going to show you. Okay. Now, after that, I'm going to come here. I'm going to reach that point. So after there, this is how our sketch is going to look like. And now I'll come here and I say, this is my north still. Here is my north. Here I'll indicate 120 degrees. Now, what do I want you to notice is that when you check, then they told us the speed was the same. So I will say the distance between C and D. So the distance, we shall say 6 times. Since the speed was the same, the speed I think was what? Was 50. So I will say 6 times the 50. And what do we get? 6 times 50. That will give us, is it 300? It will give us 300 kilometers. So here I'll indicate that this is 300 what? Kilometers. Now, after drawing that, I will put D. Then I continue to read through the question, determine the distance and direction of F from D. Then they want also to get this. So I will join something like that. And then I say determine. So that is the simple sketch I can have. Don't forget, you say a sketch showing Pamela's journey from A to D. So that is how you write a sketch showing Pamela's journey from A to D. Then you have a simple sketch like that. Now, I want you to use the chart. Tell me. Now, the next part is after drawing that, don't forget to include the directions. Then, the next part is that now you are going to ask yourself, here, I have turned, this is the 120. Members, how many, if this is 90 here, how many degrees are here? How many degrees are here? In between here. How many degrees are there in the chart? How many do we get? Very good. Thank you, Ruth, Francis, and the rest. So here we have 30. So meaning that when you are placing your protractor, still you'll place your protractor the way we said, like that. And then measure off the 30. Though for here now, you are going to use the inner scale. So you'll come here, like this is your protractor. Sorry, this is your protractor here. So here you use the inner scale. So you have placed here like this, and this is where your 30 is. So I'll come, I draw something like that. So this is where the 30 is. So that's how you place your protractor at that point. Okay, now may I ask you in the chat to tell me which scale do you think we can use? We have 200, 400, 300. Which scale are you going to use? 100. Frank wants to use 150. Gilts, 100, 200, 100, 150, 150, 150. Okay, now, we go back. When something is very tiny, Bananga, at times it looks ugly. Let me take you back. Now, in case you decide to use, remember you have 200, divide by 100, those are 2 centimeters. When you have 400, divide by 100, those are 4 centimeters. 300 divided by 100, those are 3 centimeters. So you are going to find your thing that you are going to draw. It's going to be a very tiny thing. Though it is correct, I want to let you know it is correct, even if it is very tiny. But you are going to find challenges taking some measurements, more so for angles, when it is very small. So now for that particular one, the best scale would have been a 50. The best scale would have been a 50. The best, yeah. Though also your 100 is okay. 200 is very bad. 1 centimeter, 4 centimeters, and 3 centimeters, it would be bad. So here, can we use a scale of 1 centimeter to represent 50 kilometers? Now, afterwards, we said you must show how you are converting. So I'm going to say, come here and say, the distance between A to B. So I'll say 200 out of 50. I will get my answer. So 200 out of 50 is 4 centimeters. Then I go distance between maybe B and C. What is it? 400 divided by 500. And this one will give us 8 centimeters. Then the distance between C and D. So here you say 300 divided by 50. So, okay, this is 50, not 500. 50, this one will give us 6 centimeters. So having 4, 8, and 6 is very okay. Then you look at your graph, check, because you must make, you must first think, how is my graph going to look like? You are noticing that your graph is extending towards the right, meaning that when you come on your graph here, it means that you are going to leave, you must leave a lot of space towards the right. So you can leave 1 centimeters or 2 centimeters, then leave an appropriate, just a small distance this side of the left, and then you sketch well. So can we now make a sketch? I repeat, someone wanted me to throw some light on C. She then maintains the speed for another 6 hours. Like when you are moving, imagine you are going to Busoga. Okay, those who have been to the Nile, let me use that route. When you go to the Nile, you go. As you are reaching Nile, you instead of continuing to the Nile, you turn your left. So turning your left, this is the left. So it means that you are going to turn. And when you turn on your left, when you reach the Nile, you are going to be heading like you are going to Kayunga district. So for you, just imagine, you have been moving like this, and suddenly you turn to your left, you turn like that. So that's what I wanted you to notice, that when you reached here, when you have reached a certain town, you turn. It's like you, many times when you find maybe a teacher, most of the teachers you fear, you'll find a teacher as you are coming, maybe you're going maybe to somewhere to do something. But since you have seen the teacher, you return very quickly, either on left or right. You cannot continue in that direction where the teacher is coming. So that is the meaning. So turning on your left, you look at your hand, the way you have been moving, Then look at your hand. In case they say right, you turn this side downwards. They say left, you turn like upwards. Okay. Now, we are doing the accurate diagram. So we are doing the accurate diagram. Let us start. Remember, for the accurate diagram, where we have our 200, this one is going to be equivalent to 4 centimeters. Where we have 400, this is equivalent to 8 centimeters. Then here is equivalent to 6 centimeters. Let everyone now draw the accurate diagram. Now I have Daniela.
Good morning, teacher.
Yes, good morning.
I wanted to ask what determines the inner scale and the outer scale when you're placing the protractor? What do you use to determine if you're using the inner scale and the outer?
Now stay on. Now, what determines when you are moving, when you are measuring angles, in the clockwise direction, when you are taking the clockwise direction, you consider the outer scale. Are you noticing? When you are moving in the clockwise, even if you have placed it vertically like this, as long as you are moving in the clockwise, you always consider the outer scale. But if you are measuring counterclockwise, and you want just these degrees here, then you consider the inner scale. I don't know whether Daniela, you have got it. Daniela? Okay, hope you have picked that. Okay. Then Akram. Akram. Okay. Francis. Okay. Guilds, what?
Yes, master. For me, just asking on this, on the sketch. For us, we were told that if you are coming up with a sketch, for example, this sketch here displayed, that we should make it at least to, like, for example, when you're writing this 200 and this 400 kilometers, at least the 400 kilometers should be like slightly like longer than the 200 so that it brings out the picture clearly. So is that also highly considerable?
Okay, it is not highly considerable, but it realistically makes sense.
Yes.
So it is realistically makes sense. So it is okay. That one is very, very fine. So you make it a bit slightly to show. That is okay. But there is no penalty. Okay, but that is good. Okay, Evelyn. A sketch is the representation of the actual thing. Evelyn. Evelyn, unmute.
Teacher,
Evelyn, I don't know what's happening because I think you keep muting yourself.
Okay, teacher, can you hear me?
Yes.
Yes, I'm saying that when the lady turns 120 degrees, I get that she turns to the left. But you told us to begin from the north when you're turning, and for you began from the east.
Oh, now
So I
here,
don't.
okay, Katas, Evelyn, now what you need to know is that that statement describes what we call a relative change in the direction. Because initially, she was like the way I've told you that initially you are going like this, then suddenly you turn on your left 120 degrees. So when you turn on your left 120 degrees, you measure based on where you were heading. So you measure from based on where you are heading. Number two, even if you take it that you measure from 120, even your sketch would have looked like this. Allow me to draw it for you. If you had said 120 degrees to the left and you take it, you would have had something like this. Oh, sorry. Let me just put for you blank slats. If you had taken it, like initially you are moving like this. This is the direction you are facing. Meaning that when you reach here, it means that you just turn. So you measure from where you are. But that scenario you are talking about, it means you'll have gotten something like this when you reach here. So if for you want to measure 120 degrees to the left, it means you take this direction. So meaning your 120 would have been here. So you ask yourself, can this question make sense or does it make sense? Why? When we have an island, it means that it is like a place whereby it is all surrounded by water. So if you have something like this, it means it is not surrounded by water. So it is counterproductive for you to take this direction to come like this and this, yet you can just move straight here. So, but if you analyze it very well, you note that you can come like this and you come like this. So mean that an island is somewhere here. So you cannot just cross it directly from here like this. You can't because there is an island. So you take a route. I don't know whether, Evelyn, you are getting the point. Evelyn, is it still on? Evelyn, are you getting it? Trinit Cutters. Yes, Cutters?
I'm getting. Thank you.
Yeah. So at times, and I want to let you know that for these new curriculum questions, always relate it to real life. Have that kind of relation with the real life. Yes, but I want to say that at the moment, some of the questions on the market, some of the questions that are being set are not so standard, are not so standard, being that it is your first time. They are not yet, but with the time, after I think 5 years, good questions will be available. But at the moment, you'll find that some questions you may do it and doesn't make sense. So not all questions you are meeting are good. They are because at times your teacher, all the teachers sit down and they come up with something. And yet here, it requires that when you come up with something, you sit as a group, you analyze it very well, of which time that they don't have. But for UNEB, expect something very good, something very standard, because it goes through a panel. It goes through a panel of about 10 people. So all of you do it, and then you come up with a good conclusion, and they make different adjustments. Yeah. Yes, hope we are doing the accurate diagram. I want to look through the chart and see whether members are finished. In case you have finished the accurate diagram, indicate in the chat. Yes, Prixen. Hmm?
Good morning, sir.
Yes, good morning.
Okay, all I'm asking is that why is it that you have the angle that we weren't given in the question?
Which angle?
135.
100? No, 135 came in because they told us that the person moved southeast. And when we are measuring angles, always we have said we start from the north line and we turn clockwise. So when I'm giving directions, I'll give my direction or I'll indicate on my diagram basing on what I have. So they gave us southeast. Now you need to know that southeast is equivalent to 135. So southeast is equivalent or is the same as 135 degrees. Southeast these are just words. And on bearings, we don't put words. We put the angle, the real bearing. So that's why we have it. Okay, looking through the chat, I think members are all okay. Some have not yet. We give them some few minutes. Nalwama.
Good morning, teacher.
Morning.
I'm sorry to disturb you, but I want to repeat for me from B. I've not understood. I've not understood this point. She then maintains the speed for another 6 hours.
Yeah. Maintaining. Okay, maintaining meaning that you use the same. You don't change at all. You drive. Let me use. I don't know whether you have ever found the president's convoy. Have you ever found it?
Yeah.
Now,
Yes.
when the president's convoy is taking off, the speed is the same everywhere, whether there is a up or not. So it means that that speed is constant, is the same throughout. In fact, even when those people meet those corners, there is a way they really negotiate the corners very well. So this person here still was having almost the same scenario that he was going. The speed remained the same. So when he reached somewhere, he just suddenly turned and he went off.
Yes.
At the same speed, meaning that the speed from C to D is the same. So speed will be the what? They told us because she was initially using 50 as she was heading to the east. To east is like going to Mbale. As she was going to Mbale, she was driving at 50 kilometers. Then maybe when she reached Jinja, she noticed, I forgot something in Kayunga. So she turned on the left and went back to Kayunga. That is the meaning.
Thank you, sir.
Okay, I think people have finished. Is it Naish? or Thomas? Okay, now I go to the accurate diagram. Now, when I go to the accurate diagram, kindly look at mine. This is my simple accurate diagram. How many of you have the same thing? Indicate in the chat that I have the same. If you have the same or something, okay? What's he saying? Yes. Bless is saying yes. KG is saying yes. Okay, yeah, I think people have the same. People have the same. Oh, yes. Now, official, we don't indicate kilometer per hour is speed. Kilometer per hour is speed. So we don't put speed on our diagrams. We don't put speed on our diagrams. Okay, good. Now like I've told you what the qualities of a good graph. Have your title. This is my title. Sorry, that is my title. An actually diagram showing the journey of Pamela, or the journey Pamela took from A to D, or you can say an accurate diagram showing Pamela's journey from A to D. That is very okay. I've clearly indicated my scale. That is my scale, what you are seeing. This is the scale. So here, they will score me very well. Then you are noticing that on my compass points, I've indicated that this is N. I have put the angle. This is 90. So here I write 090 degrees because that is towards the east. Then here, I have indicated the 30 degrees that I have turned. In case you, even if you, when you indicate this is also very okay. When you say 120 degrees, that one is also very, very fine. 120 degrees. In fact, it is the best, putting 120 degrees, but you need to know that the angle here is 30. Indicate your 6 centimeters. Hope you are seeing the arrows. Indicate the direct route, indicate the cities. So this is a good graph. Okay, I'm seeing, okay, those who have not yet finished, kindly make sure you get something like this. Owen. Oh. Thomas?
Morning, teacher.
Yes, morning.
My question is, we are told that you can use land, like you can draw the graph horizontally. Is it possible?
That is when you have used a very big scale, which is bad. And I want to advise that, always, when you find yourself that the graph is going a bit, or that you are going to need a horizontal thing to tilt your graph, that one shows you that you don't know how to choose a good scale. That one is one of the weaknesses. It means that you don't know how to choose a scale, a good scale that is appropriate. So that is an indicator that maybe at decision making, you still have some issues. So I advise, because that one will mean someone has to change your paper, to tilt it, and to mark you. And that one, at times, people don't have a lot of time. So I advise have your graph in the vertical way. What is important is looking for the right scale. Okay.
Okay, good morning, teacher.
Yes, good morning.
The only thing that confuses me is the actual diagram where we put the centimeters instead of the kilometers.
Yes. Now, do you know how long a kilometer is in real life?
Okay,
Do you know a kilometer?
Yes, teacher, I know.
A kilometer, I want you to, are you seeing your pitch? You know pitch, a football pitch, eh?
Yes.
From one goalpost to another goalpost, you know how many meters are there?
Not really.
There are 100 meters. 100 meters, eh? And a kilometer is bigger than a meter. So for you, you ask, if you put here 400 kilometers, for you in real life, does it make sense that from this, only this part here is 400 kilometers? Can it make sense?
No. My point was like, okay, let's say this is the actual diagram supposed to indicate the actual information given to you by, okay, like let me say in the question. Now, in case someone like needs you to illustrate his or her journey to a specific place, and you're meant to give him the graph as it is, let him say this one. So if you give him the graph and it shows that from A to B is 4 centimeters, like there's that confusion. Can that person get that confusion?
Now that is why you put a scale. Do you know this? The use of this scale. Are you seeing this scale?
Yes.
That is the meaning.
Okay.
And if you look at geography, now in geography, when you look at those maps in geography, for them they will put for you the scale that 1 centimeter is equivalent to maybe 50,000 on a map.
Yes.
So that's why they put. But those things in geography, I think you measure them in centimeters as well.
Yes.
So always it is in centimeters.
Yes.
Okay. Okay. We go to the next part. Now the next part wanted us to determine the distance and direction of A from D. Here, when they tell you from D, it means that your compass or your angle must be measured from D if there were a direct route. Now I go back to my diagram. Now, meaning that I'm going to place my protractor at D. This is where I'm going to place my protractor at point D. This is where my point D is. I place my protractor, I place it like this. Now, here we have said we use the outer scale. So here you have 0, maybe 10, 20, 30, and the rest. So first measure off which angle do you have here? Not forgetting that you have to add on this angle here, which is 180 already. So find out which angle do you have here. Now, the angle you have here is what you add on 180. So you tell me, we are going to have 180 plus which angle are you people getting for you? Antonio is getting 70, 75. That is Bridget. And the rest are still measuring. 73, 73. Patricia is getting 73. I think Patricia, we are getting the same 74. Low, okay, 73, 73, 72. Okay, the angle is there. Personally, me, in my when I was doing, I got also 73. I got 73. But those who are getting yours, it is okay. Don't say it is wrong. Because when they are measuring, or when they are awarding, they give in range. They give in a range. So your total angle now, you will say 180 plus. In case you have got 73, put 73. 75, put 75. And therefore, your total angle, I think I saw already Ruth told us 253. 253, Teddy, 253. Good. Now I'm going to come back here on my question. I say part B. Please don't forget to label. Clearly keep on labeling on your question. Part B. Then you say that the direction of A from D is on a bearing of 253 degrees. But the same question, when you look at they told us, and the distance and the direction. Then what is your distance? When you measure for you, what are you getting? Me, when I measure from A to D, what are you getting? You can place in the chat what you got. Fugo Nerima, that is good. 73 plus 80. What were you getting? What is that distance? How many centimeters? You can first tell us the centimeters. 8.38. Some are getting 8.38. Okay. 8.2. Kathe, I think we have the same. Faizo, we have the same. People who are getting 8.2. Hope we have the same. Trace, we have the same. Yeah. Those having 8.2, you got the same like I got. Then the rest, it is okay. You are within the range. Now, what do I want you to do? Now, when you come back here, you say that my distance is going to be 8.2 times the 50, which will give me 410 kilometers. So here in your conclusion, you are going to say the direction of F from D is on a bearing of 253 and the distance from A to D is 410 kilometers. Do not forget to show this part when you are converting, because you said earlier 1 centimeter is equivalent to 50 kilometers. So that's how you make your conclusion. And always, in case you happen to see that the marks are indicated on the paper, always let them guide you. That if you see 5 marks, it means you need to give a good conclusion. But in case the marks are not committed, please make sure for you exhaust everything you feel is right. Do not limit yourself, because what you might be limiting might be the correct thing. Okay, Francis. Okay, then the next part, how long would it take a helicopter?
Teacher.
Yes.
Teacher, on part B, they asked for the direction of A from D. So now you hear from D. So shouldn't your arrow on the actual diagram be facing towards A from D?
Okay, if there were a direct route. Did you see that word? If there were a direct route, in other words, if there was a direct route from A to D, remember, the intention of the person is to move from A to D. I don't know whether we are getting it. Francis?
Yes, sir. Yes, sir.
Because your intention is to move from A to D. You are not interested from moving to D to A because that's not where you are. You are at A. Okay.
Okay. Thank you, sir.
Okay. Gilitz and Glasgow. Then the last one, how long would it take a helicopter moving at an average speed of this along the direct route? Give your answer in hours and minutes. So still you come back, you do the same thing. Always, like I've told you, don't abbreviate, use the words. Use the words, I repeat. Now you'd say that time is given by the distance. In fact, here even you can be very good and say the direct distance out of the average speed. Then you say, what is your direct distance? According to the one we got, it was 410 out of 200. And here your answer is going to be 2.05 hours. But like I've told you that when you write like this, it doesn't make sense. Give it in the units that are easy to read. Even if they have not stated it, for you put it there. First put your 2.05 hours, then put it in the easy hours. Say, these are, let me see. How are you going to make your conclusion now? At least we have talked about it. Let me see people whether they can give us a good conclusion. Give us a good conclusion. 2 hours, 45 minutes. That is Uthman Ryan. Ryan, check. 2 hours, 45 minutes. Teacher, I'm having 2.0. How do I? Okay, Antonia. Antonia, now what you do, these are hours and these are hours. So what you do, you say 2 plus 0.5 hours. But you know that in 1 hour, you have 60 minutes. So you ask in 0.5 hour, oh, sorry. In fact, there's another 0 here. It is 0, sorry. I have to write it, in fact, in a good way. I have to write it in a good way. This is 2 plus 0.05 hours, if you can see it very well. So these are already 2 hours. Then you ask, what is 0.05 hours? So in 1 hour, you have 60 minutes. So in 0.05, you say 0.05 times 60. So 0.05 times 60, I think that is about 3 minutes. So you will say now, it will take the helicopter 2 hours and 3 minutes. Now here, I want you to be, now in case you are getting, now like Antonia was getting here, you would have said 2 plus 0. Did I see 0.075? So here for you, what you do, you say 0.075 times 60. Then you find out how many minutes are those. 0.075 times 60. You end up with 4.5. Now, 4.5, you approximate it to 5. So here you will say 2 hours and 5 minutes. Now here, I want you to, because you are not accurate, you are not so accurate because we cannot be accurate. Here in your conclusion, I want you to use the word approximately. There you are going to sound scientifically because you are not sure. You saying the helicopter would take 2 hours, 5 minutes. It shows you are sure. But are you sure of that? So you say it would take the helicopter approximately 2 hours and 3 minutes to travel directly from A to D. Members, let me know whether that is very fine in the chat. Your conclusion, that we don't commit ourselves. We say it, okay, I repeat. Yeah, I'll repeat. The conclusion I would say, because you are not sure, you might have made errors in measurement, you might have made errors here. So you would say it would take the helicopter approximately 2 hours and 3 minutes to travel directly from A to D. Now, people who are getting points here, when you are getting points, maybe for you have got 2.075 or what. Now, for you, what you do, here, you just say this is 0.075. So these are 2 hours. Then here we will get 0.075. So this 0.075 is the one you convert to hours. Because in 1 hour, you have 60 minutes. So you say, what about 0.075 hours times 60? You get your answer. The answer you get are going to be in minutes. Then you add on them on the 2 hours that you already have. Yes, Guilt, I'm seeing your mic open. And Thomas?
Yes, Master, I was asking that is it a must to indicate the arrows on the routes?
Very, very important, because I've told that bearing is made up of 2 things, angles and a direction. Hey, without those 2 things, you are not doing anything. Because do you know that when someone comes on your diagram and he changes this, do you know that that one is something very different? Yes. So the arrows are very, very important. Never, you'd rather forget anything, but when you have not forgotten the angles and the arrows.
Yes. Another thing is on the scale, and we use the ratio sign. For example, instead of saying 1 centimeter equals 50, can I say 1 meter to 50 kilometers?
Yes, it is very okay. I think that's what even used in geography.
Yes.
Hey, that is very okay.
Thank you.
Okay, teacher.
Yes.
Okay, my question is, when they tell us to describe the direction, let me say of A from D. Like when for me, I write like let me say it is northeast and I don't indicate the bearing. Is it incorrect?
Now, when you say northeast, me who's looking at your work, it means you have moved 45 degrees. But is the angle 45?
So if we indicate the bearing, we don't put the direction like northeast or another.
Yes. In bearings, the moment I find 135, this one shows me that you started from north and you turned towards south.
Okay.
Yes, there are 2 ways of writing bearings. Either putting these digits, putting NS, those ones. But see, even when you put those ones, you must put the angle that you have turned through. Otherwise, if you don't put the angle, then unless when the bearing is exact that for you have worked out and it is northeast, that is okay. But I've told you that bearing is made up of 2 things. It is angle, because I've told you that bearing means bearings, like in simple terms, when someone asks you what is bearing, how do you understand a bearing? For you, when you are explaining to a local person what bearing is, for you, you just tell him that bearing is just describing something using direction as angles.
Okay.
Yes. So
and
in fact, even
like that number part, this part do where it says that like is it estimating the time the plane will reach? Like in most questions, like say other questions, is it a must? You have to also say like approximately that's taken this time, or is on in this specific question?
No, like in those questions that involves you measuring, that involves you taking measurements, your own measurements, we cannot be accurate. So that's why you say approximately.
Okay.
Okay, now can we also draw a sketch for this one? Everyone, try. I want you now to first try this one as well. And that one we have completed the number. and let me hope we are pocketing. Anything we find on bearing, we must at least go away with a 20 on it. Me.
Teacher, so since you said that time, you say approximately, then for the distance, do you also say approximately? Because there might also be errors in the distance.
Yes, it is. Anything you do for measure me, it is very fine.
Okay, thank you, teacher.
Okay. Yes, we are trying this one now. Prixen.
Morning, once again. Okay,
Yes.
I'm sorry for the interruption, but okay, like, I'm sorry for the interruption, but I'm still lost on this part of 135 degrees. Yeah. Okay, could you help and explain this one?
135 what?
135 degrees. Remember, it wasn't given in the question.
Yes.
Like, it wasn't given in the question. That's what
Like
I'm asking.
in the question,
So how did
Prixen, you stay on. Are you not seeing that in the question they told you in the question that that person moved in the southeast? Not so? Now, we said this is south and this is east. Southeast is here. This is the thing. Then you ask yourself, if this is southeast, what is the bearing of southeast? The bearing of southeast is this bearing here. Now you ask yourself, which angle is here? That if something is southeast, remember it divides south and east into two equal parts. And the angle you have here is always 90. Meaning that here you have 45, here you have 45. But you know that from north to east is 90 degrees. So to reach where southeast is, it means you are going to turn the 90 and then you add on the 45. So 90 plus 45 is what gives us that 130. What? That 130 something we have, 135.
Okay, thank you, sir. I'm good.
Okay. Kalimanol.
Good morning, sir.
Good morning.
Is it a must that always to read the bearing starting from north?
Yes, it is a must. It starts from the north when you are measuring any angle. Anything with bearings, those are the conditions. Have it in the head, bearing must start from the north and always you move clockwise.
Okay.
Prixen. Okay. Anne. Anne. Mike.
Good
Okay,
morning,
Anne.
teacher.
Yes, good morning, Anne.
Yeah,
Teacher,
like
I would
when does
like
this
to
thing
know
of adding come
the
in?
convenient scales.
What?
I would like to know the convenient scales.
Oh, the convenient scales, I've said the convenient ones are more or less like the one is in physics. 1, 5, 10, 10, 50, 100. Those ones are very convenient.
But then we were told that even 2 and 2.5 are convenient. Was the
Okay.
teacher right or?
Now, when we are, like here I'm talking about in math, 1, 5, 10, even 20 is okay. Then when it comes to physics, the best scales is 1, 2, and 5. Then 2.5 is at worst. That one comes in that dangerous time where you have tried everything and things have failed. That one, in fact, that's why I say 1, 2, and 5. Then at worst, that's when you bring in the 2.5.
Okay, thank you, teacher.
Okay.
Morning, sir.
Yes.
Yeah, like when does this thing of adding come in? Like where you added 90 plus 45?
When does it come in? One, in situations whereby they have given you those directions in words. Let me say they have said northeast, northwest, maybe southwest, when they have put for you these ones. That's when now you can bring in those addition thing. When they have not specified the degrees that have been turned through, but when they have used words to describe.
Okay, thank you, sir.
Lozon, hope everyone is trying out this sketch before we do it. Lozon. Oh, okay, I'm failing to get Lozon. Yes?
Yes, sir. I'd like to know that like all bearings are supposed to start from north, but there was
Yes.
another bearing. When maybe Mr. when a person moved east from there, he just turned like this and it never started from north. How are you
No,
supposed to?
when we are measuring, I don't know that you notice, I told you now, when you are measuring, this is the north. So you notice that we measured 30 degrees from the north.
But you started measuring from east. The total bearing was around.
Yes. Oh, now, like I told you that was relative positions, But after drawing your compass at point C, when you are measuring, you start from the north and you measure those degrees. This 90, we just add it to show you out that you went 120.
Okay, thank you.
Okay, let me hope now people have finished the sketch. Yes, I've told you now we are doing only mock papers. Now, this was also a mock paper. And I found this number very interesting. So they told us that in a bid to reduce the malaria infections on islands, the Ministry of Health supplies mosquito nets to these islands. A skipper is to distribute mosquito nets to 3 islands. He normally moves at an average speed. He normally moves at an average speed.
Okay.
He always moves at an average speed of 60 kilometers per hour. It takes him 20 minutes to offload the package at each island. Now, that statement was very crucial. It takes him 20 minutes to offload the package at each island. The skipper sails from Bubembe at 7 a.m. the northeastern direction and arrives at this. Now, we said you write here down up here and say a sketch drawing showing, tell us what is showing. Showing the distribution of the showing the 3 islands where the nets are being distributed, or showing the 3 islands. Now, what will happen? You first draw your north line very well. Let me be now. Let me remove it. So I'll come here. I draw this is my north line. So I will say, they have told us that this skipper sails from Bubembe. So I'll come here and say, this is the Bubembe Island at 7 a.m. So here the time he's starting his journey is 7 a.m. in the northeastern direction. So it means this is north and this is east. So we say that northeast, meaning that this is north and east. So it divides into 2 equal parts. So since this one from north to east is 90, here we shall have 45 degrees. So I'll come here and I put here that my bearing here is 045 degrees. And they told us that, and arrives at Damba at 8:30. Now I'm going to come here and I say, this is where we have the Damba Island. And which time did he reach here? This person reached here at 8:30. Now, when you notice, they have given us the time, but they have not given us the what? The distance. Yet on our bearings, on our sketch, we are interested in that distance. So what do we do? I want to see whether people now know how to subtract time. How long did it take this person to move from Bubembe to Damba? How many hours? How many hours? By show, you type in the chat 2 and 1.5 hours, 1.5 hours. Very good. Yes. So you notice that here you will say 830 minus 7. So here it will be 0:30 and 1. So it will take him 1 hour and 30 minutes. Then you ask yourself, what distance will I have? Then I will say here, distance between Bubembe and Damba. So we say that distance always given by speed times time. But they told that he normally drives at an average speed of this. So I will say now here my speed is going to be 60 times the hours. Now you convert the 1 hour and 30 minutes. Since here the distance is given in kilometers per hour, you convert the 30 minutes to hours. So here will be 1 hour plus 30 minutes. So 30 minutes is the same as 30 out of 60. So this will give you 0.5. So this will be 0.5, which is going to be 1.5 hours. So here I'll come and I say this is 1.5. Then I multiply my 60 times 1.5. So 60 times 1.5, I think that is about what? 90? What is it? I think it is 90 kilometers. So that is now what you are going to indicate. So here I'll come and I put 90 kilometers. Now they told us that immediately after offloading, the skipper sails east. Now the skipper is going to sail towards the east. And here our bearing is going to be 90 degrees. Now, immediately after offloading, the skipper sails east of Damba and reaches Koome Island at 9:30. Assuming that this is where we have our Koome Islands here. So the time he reached here was 9:30. Now, let us use the chart. I want now to check out how long did he take what is the time from Damba to Koome? Now that is where now it tested our thinking. 1 hour, 1 hour, 1 hour. Now 40 minutes, 1 hour. Now that is where it tested for a lot of thinking. Because remember, at 8:30, that's when he reached Damba. But he must offload. So, and it takes how many? 20 minutes. So the time he left Damba, it's going to be 8:30 plus that 20 minutes. See, because he took 20 minutes to offload. So meaning that the time he's leaving Damba is going to be 8:50. People were getting 1 hour. Now it's going to be 8:50. So now you have to count that from 8:50 to 9:30. How many minutes or how many hours do we have? Hope members, we have got that. So because he has to offload fast, it took him 20 minutes. Okay. Hope that is okay. Now, after that, hope everyone now is seeing the 40 minutes coming. Are we seeing the 40? Now people are seeing the 40 coming. People are seeing the 40. Good. Now, because there you are going to say, he reached the other side at 9:30 minus the 8:50. So remember, when you are borrowing, this is 1 hour. When I borrow 1 hour here, I remain with 8. 1 hour has 60 minutes. So here, instead of having 30, we shall have 60 plus 30, which will equal to 90. So here we'll have 90. So 90 minus 50 will give us 40 minutes. So here, it will take him 40 minutes. Now you go back, that distance is equal to speed times time. But when we come here, our speed remains 60. Then the time is 40 minutes. So we converted the 40 minutes back to hours. So it will be 40 out of 60. Now, this is why I want to emphasize that whenever you find yourself having fractions, please first work with the fractions up to when you reach the final answer. So I don't expect you to come here, 40 out of 60. In case maybe some of you, now here, in case those people who divide, you get 0.66. Please don't work with the decimals. First work with the fraction. So here I'll come, the time I'll set 2 and 3. So I'll multiply my time 60 times 2 and 3, which will give me 40 kilometers. Now for people who use decimals, let me say for you, say 0.67. Here you are going to get an answer that is actually 0.67. When you multiply, you'll get 40.2, meaning that you are not going to be accurate at any one point. So when you find yourself getting fractions, we'll first work with those fractions. in these things of calculating. Then at the end, that's when you can calculate. So here we shall have our distance as 40 kilometers. Then we continue. Now, at what time is he going to leave Koome? Let me see, people. At what time is he leaving Koome? Type in the chat. At what time is he leaving Koome? At what time is he going to be leaving Koome Island? Good. It's going to be at 9:50. So at 9:50, is leaving Koome. So I'll come here and I say the time. What's happening? Okay. At 9:50 is leaving Koome. So here I will say 9:50. Now, they told us that after another offload, he takes southwest. Now, you need to know where is southwest. This is where we have south, and this is where west is. So southwest is this direction here. But we have said that since southwest always divides south and west, so the angle you have here is going to be 45 degrees. So now you have to indicate that this is the angle that you have turned through. So this is 45 and this is 180. He takes southwest direction to sail to Mageta Island. So this is where we have our Mageta Island. Now the distance here, they gave you that the distance between Koome and Mageta was 50. So here you had your 50 kilometers. Now that is now a simple sketch that you must have had. Members, have we understood that sketch? Okay, good. Rosalind, let me know. Now, if we have understood, I want you to tell me which scale are we going to use for our accurate diagram. I don't know whether Rosalind, you can unmute a bit. Rosalind.
Yes, teacher.
Yes, which point?
Actually, I got confused from Damba to Koome.
Damba to Koome. Now, they told us that he reached Damba at 8:30, not so?
Yes.
In simple terms, how do you understand offloading?
Like giving out the goods, like delivery.
Yes. So if you reached at 8:30, let me say you are going back to school and you reach at 8:30, then they have to check your things and the rest, and you take 20 minutes. So what time are you going to leave that checking point?
At 8:50.
At 8:50. Now, if they tell you that you reach the dormitory at 9:30, it means that now the time you took to move from where your property was, from the checking point to dorm, you'll get this time you reached the dorm, which was 9:30, minus the time you left the checking point, which was 8:50. Are you getting it? But
yes.
Here now in a time, since this is 30 and this is 50, 30 is smaller than. So you have to borrow. When you are borrowing in time, these are 9 hours. So what I do, I remove 1 hour. I remain with 8. But since we are taking it to minutes, 1 hour has 60 minutes. See? So here I take 60 minutes. But these 60 minutes I've taken, I add them on the previous minutes, which were 30. So 60 plus 30, I get 90. So after I say 90 minus 50, which gives me 40 minutes. Then 8 hours minus 8 hours is 0. So I end up with 40 minutes. Now, after getting the 40 minutes, you convert them to hours. Again, since your speed here is in hours. So you say in 1 hour, you have 60 minutes. What about in 40? In other words, whenever you are converting from minutes to hours, just divide. So say 40 out of 60. Is that fine?
Yes, teacher.
Okay. Are we on the
Thank
same
you.
page?
Yeah.
Okay. Now. Okay. Some people are saying a scale of 5. A scale of 5, 10, 20. Okay. People have different scales. That is good. That is okay. So kindly use the scale you want. I don't know which one you are going to use. Which scale are you using? I don't know which one you are going to, 10. Okay. Okay, we are going to use 10 because it is really very convenient. Okay, 1 centimeter represents 10. Kindly let's go on now. Yes, kindly let's go on. Esther Wafla and we do the accurate one. Yes, and I want the person who was, when you finish, I want someone who's going to take for us a screenshot of your your thing you have drawn and you share in the chat. You take for us a screenshot or a photo and you share in the chat. Then I saw RSA. RSA, you had a question. RSA, unmute. RSA.
Sir, I've not understood the distance of Mageta from Koome.
Oh, it is here.
Like how to get it.
I think the hint, it was given in the hint.
Oh. Okay, thank you.
Okay. Now we are drawing. Get your equipment and start drawing the accurate one. So mind you, we have to time ourselves that the diagram shouldn't take us very many hours. Okay, I think. Okay, let's draw. Yes. Okay, we are drawing. Oh, I am obstructing the sketch. Okay, hope now it is clear. Oh, I was reading through the other question. Now, okay, I've seen the number. Okay, I've seen the number. Now, one thing I want to let you know is that many of the questions have to be realistically what we call real life questions. There are some questions that you'll find that it cannot happen, because always ask yourself, how can it happen? Can this one happen in real life? Yes, and that is the way the questions must always be set. Yes, there are some questions you are going to reach on and you read and even you fail to interpret. Yes, but I want to just let you know, when it comes to the UNEB, expect all the questions to be real life related. Real life related. Things that you can visualize if you think critically in your life. And if you have noticed, some of these questions we are doing are real life. Those people who have been to these islands, Damba, Koome, and Mageta, you'll find that you will have a situation of that nature. So not all questions you are finding in past papers or in mock bodies are good. Yes, and but you can look at the ones I have been sharing with you, the questions, you'll find that there is something called a real life related. So I know, and some of these ones I first go through them, I read through them. In case it makes sense, I go on and we do it. But in case it doesn't make sense, then do not expect anything from it. Yeah. So please, even I've seen now, I saw very many questions from different. Yes, I saw very many questions from what? From different seminars. Please, if you do a question and you are spending more than 7 hours or 6 hours or a lot of time on them, then please take note that some of those questions are not real life related. So you'll not meet such situations in your name. Yeah. So in other words, what I'm saying, let them not take your time thinking about them. So let's draw. Okay. I don't know whether Nerima, you can share with us a photo in the chat. I don't know whether you can share with us a photo of your graph you have drawn in the chat. Okay, Ruth, you can share if you can share. Yes, I want to use one of those who have finished, share in the chat. I want to download one. Those who have finished, share. I want to pick one sketch from the graph, from your what? For those who have finished. Okay. I'm waiting for someone who can share. Okay, I don't know that someone has shared. Oh, okay, I'm saying no one is really sharing, but it is well. I think it might not be an easy process. But those who have my number on WhatsApp, you can share with me, but it is okay. Then I can continue. At what time did the ship arrive at Mageta? Now, when you look, this is Mageta, and this is what? Where we have our Koome. Now, what are you going to do? You're going to go back and ask yourself that, what is that? Okay, wait. Okay, now I'm going to, I don't know that, let me look for, okay. Okay, let me first do something. Okay, now to get part B where they wanted us, so still we shall go back and say that distance will equal to the speed times the time. But what are we interested? We are interested in the time. So we shall say that time is given by the distance out of the speed. But which speed are we using here? We are using what we call the average speed. So this is our average speed. Now, the distance, according to the hint they gave us, they told us it was 50. Then I divide by my speed, which was 60 when you look through the question. Our average speed was 60 and then the distance was. So I'll come and I say, this is the same as 5 out of 6 what? Hours. Now, after obtaining 5 and 6 hours, I've told you must reason. So you ask yourself that how many minutes are there? So you say 1 hour has 60 minutes. So you say 5 divided by 6 times the 60. What do I get? You can even do it as rough. 5 out of 6 times 60, you'll end up with 50 minutes. Meaning that it took the person 50 minutes to move from where he was, Damba, to Mageta. Now, after, yes, for the ship to arrive at Mageta. But now, remember, we said that he reached this Koome, he reached the Koome at 9:30. But after he had to offload, meaning that he left at 9:50. So now you come here and say now, if the person left at 9:50 plus the 50 minutes it took him, what time did he reach the final point? So 9:50 plus 50. These are 950 plus 50. How many? Or you can add them. You can just say like this. So, so what time is that? 10:40. 10:40. Okay. So this is going to be 40 and this is going to be the 10. So meaning that this person, this is AM. So you are going to come back. Okay, I've seen someone who has drawn it very well here. I don't know. Okay. I don't know what is on my screen, but someone has drawn it here and he has shared. Thank you. I'm going to download it. Yes, we are going. Okay. Okay, thank you, Elima. Okay. Okay. Yes. So it means the person reached at 10:40 a.m. So here in your conclusion, you are going to say the time or the ship arrived at Mageta at 10 a.m. And here take note that they used semicolons. So please indicate them as well. Then after, okay. After that, you go to the next part. Okay. Nobody, you have a question?
Morning, teacher.
Yes.
Teacher, sorry to take you back, but on the part of Koome, why did you say 180 degrees yet moved 90 degrees to Koome? Why did we start in 180?
Why did we say?
On the part of Koome, him moving from Koome to Mageta, yet he moved from Koome at 90 degrees. Why did we start here on Koome, 180 degrees to Mageta?
Like, remember, this person turned southwest here. So the bearing here, remember we measure from the north. So it is like this. So this bearing here is 225 degrees. Because I've told you first add this 80 plus the 45, which will give you the 225. Okay. Then the last one, they're asking us that describe the direction and the distance the skipper should take for a direct route from Mageta to Bubembe. Remember, this is where we have our, what is Bubembe? Okay, this is Bubembe and this is Mageta. So now, can we join the direct route? The skipper should, for a direct route from Mageta to Bubembe. Now, the direct route so now I want you to join them, measure the distance, and also measure the angle. And you place them in the chart and we see whether our answers correlate. For part B, I'm saying Momo is that already, yes. Do not forget, yes. Do not forget the arrows. Do not forget the arrows on your diagram. Okay, distance, Starboy is getting 40. Starboy is getting 40. Okay. Now, Nabukela Melissa, when you write south 225 west, that is the double, that one is wrong. Reason being is that that one is totally different angle. So please don't write south 225 west. If the angle is 225, just write 225. In case it is 250, you write 250. Seven kilometers, 225 degrees, 75 kilometers. 72. 80. Okay, so you'll find that it's going to be within that range of 70. It is in 70s, it is in 70s, 73, 75. Okay, but I know it is around 70. Yes, Kalema.
Sir, sorry to disturb you. It's about how can you position the contractor there at Koome to find the bearing of Mageta. I'm wondering. That's what I'm asking.
Here, are you seeing this diagram here?
Yeah.
So you are going to position it like that, and then 45 is here. So you position, and then you measure off 45 here.
Now I'm saying, now what if here it's like 43? So now you want to count from
43, you count
that.
40, 41, 42, 43 is here.
Okay. Okay. Thank you.
Okay. Okay. Okay, 247, 75. Okay. That is okay. Whatever thing you are getting, it is very okay. To whether you're getting 245, 247, it is well around that range. Okay. So I think you'll try out this number. I hope you have tried a number of this nature. This was the sample number. So you can try it in your free time and check out following all the things we have talked about. How do you get the degrees? We have said that now you're going to come to your sketch here, place your protractor in that vertical form. Those who are looking for degrees, Nicole, place your protractor at this point. Then remember they wanted you from Mageta, I think from Mageta. Then come, let me say you have let me say this is where you have drawn your compass. Then come and draw, let me say this is what is joining Bubembe. Find out how many degrees are here by using the outer scale. Maybe in case they are 72 or what, then after add it on the 108. Because from here up to here you have 108. Then add on those degrees. Okay. How do you get the 1040? The 1040? Where was the 1040? We have said that they gave us the distance from one island to another, which was 50. And this person was using an average speed of 60. So you'd have said 5 out of 60. So these are hours. So you convert these hours to minutes by multiplying it by 60. So you got 50 minutes. Then you come and you go back, I think towards, I don't know which class is that, where you add the hour, where you can add. So you add the 50 plus 50, that is 100. Now, when you get 100, remove the 60. So you remain with 40. So I write here 40, I take the 1 hour this side. So 9 plus 1 will give me the 10. Yes, Ruth?
No, teacher, that was my very question. You've answered it.
Oh, okay, okay. Another one, Ruth? Okay. Okay. Now, yes. So I think you can take that screenshot, you try out this number. I'm going to, okay, I think I'm going to share other numbers. Yes, let me check. I had some mock papers. Let me check whether I can get some here. Mocks. Will. I think we have done this now, the ones in this mock. So for you, just okay. I think we have done. This is distance time graphs. Was it in a water? I don't know what was capture. Let me check. There's a mock paper where there was a number I wanted you to try. But I'm failing. Was this one? Okay, I'm just trying to see. Okay, yeah, it is this one. You take a screenshot of this number. You can try it in your free time. Okay. We shall, yes, we shall start from here. We shall start from here. The next time, we shall have, in the afternoon, we shall have physics. And the afternoon, we shall have, okay, let me,